Welcome to the Cosmic Pillow. It's really nice to have you here tonight. Before we begin, just take a moment to notice where you are. Maybe you're curled up in bed, the blankets warm and the lights low. Maybe you're lying on the couch, phone resting loosely in your hand, feeling the slow tug of sleep behind your eyes. Or maybe you're somewhere between waking and drifting, that soft in-between place where thoughts feel lighter and the world feels a little quieter. Wherever you are, I'm glad you're here, and I hope this helps you unwind, relax, and maybe even fall asleep along the way. Tonight, we're going to wander gently into the strange and beautiful world of quantum physics. Not the stressful, complicated version full of equations and chalkboards, but the calm version, the dreamy version, the version that feels like listening to rain on a window or watching starlight ripple across water. Think of this as a slow nighttime walk through the smallest parts of the universe, where everything is softer than you expect, and nothing behaves quite the way you were taught it should. And if you find yourself drifting off at any point, that's perfectly fine. The quantum world will still be here when you wake up. Quantum physics begins with a simple but astonishing idea. The universe is far more subtle and far more mysterious than the everyday world suggests. The solid things around you, the walls, the blankets, even your own body, are built from ingredients that don't behave solidly at all. Deep down, beneath the atoms, and beneath the particles inside those atoms, reality becomes blurry, uncertain, and wonderfully strange. Particles don't sit in one place. They don't follow neat paths. They don't wait obediently to be measured. Instead, they exist in gentle clouds of possibility, hovering in many states at once, as though the universe itself prefers to keep its options open until the very last moment. One of the most surprising things, even now, is how normal it feels to live in a world built from things that are anything but normal. Every electron in your body exists in a haze of potential positions, and every photon that touches your skin has traveled across space as both a wave and a particle at the same time. You are made of uncertainty, woven from probabilities, shaped by interactions so delicate you can't feel them. And yet here you are, breathing, thinking, resting. Quantum physics isn't just something that happens far away in laboratories. It's happening inside you right now, quietly, continuously, forming the background hum of your existence. Scientists didn't discover this world all at once. They stumbled into it slowly, reluctantly, as experiments began to reveal results that made no sense in the old classical picture of reality. Electrons passing through two slits created interference patterns like waves of water, even when fired one at a time. Light behaved like a particle and a wave depending on how it was observed. Atoms emitted energy in tiny, discrete packets instead of smooth streams. Everywhere they looked, the universe seemed to whisper, "There is more here than you think." And the deeper they listened, the stranger the whispers became. Early physicists tried to explain quantum behavior using the ideas they already understood, tiny particles bouncing around like miniature billiard balls. But nothing quite fit. the universe was doing something subtle, something new, something that didn't want to be compressed into old ideas. So they let go of certainty and started learning the language of possibility. They discovered that particles can be entangled, sharing a connection so deep that measuring one instantly affects the other, no matter how far apart they are. They learned that a particle can be in a superposition of states, occupying multiple futures at once until a measurement settles it into one. They realized that emptiness isn't empty at all, but filled with restless fluctuations, little bursts of energy flickering in and out of existence like fireflies in the dark. And yet, for all its strangeness, there's a softness to the quantum world, a quietness, a gentleness, as if the universe becomes more delicate the closer you look. These aren't violent phenomena. They're subtle, almost shy. They exist at scales so small you could fit 1 billion of them across your pillow. They hum beneath the surface of everything, unnoticed but essential, like the faint rhythm of your heartbeat as you drift towards sleep. As we move deeper into this story, just let your mind wander the way electrons do, loosely, freely, without forcing anything. There's no rush, no pressure, just a calm exploration of a universe that is stranger and more wonderful than anything we can see with our eyes. When scientists first began to uncover this invisible landscape, many of them were unsettled by what they found. The classical world was comforting. A ball rolls because you push it. A planet orbits because gravity pulls it. Everything has a reason, a place, a path you can follow with your eyes, or predict with your equations. But the quantum world doesn't behave like that. It doesn't like being pinned down. It doesn't like being predicted. Instead, it offers you a range of possibilities and gently says, one of these will happen, but I'm not telling you which. It's as if the universe prefers to keep a little mystery for itself, hiding its inner workings behind a curtain of probability. This unsettled some of the greatest minds in history. Albert Einstein famously shook his head at the idea that the universe could truly be random at its core. He had spent his life revealing deep, elegant laws that connected everything with perfect logic, and the thought that particles simply made choices according to probabilities bothered him deeply. God does not play dice, he said, convinced that something deeper must lie beneath quantum randomness, some hidden mechanism we hadn't found yet. But experiments kept proving him wrong. Over and over, the universe behaved not like a clock, but like a shimmering field of possibilities, choosing outcomes only when forced to by observation. The dice, it seemed, were real. And yet, the more scientists studied quantum physics, the more beautiful it became. Beneath the randomness lay a startling precision, a mathematical elegance so profound it almost felt inevitable. Particles that appeared chaotic at first turned out to follow rules so subtle and perfect that any tiny deviation from them would break the universe as we know it. The equations describing their behavior weren't clumsy patches slapped together. They were works of art, full of symmetry and balance, as if the cosmos were built not just from matter and energy, but from the quiet grace of mathematics itself. One of the most astonishing discoveries came in the early 20th century, when physicists found that particles don't simply exist in isolation. They can become entangled, meaning what happens to one affects the other instantly, even if they're on opposite sides of the universe. It's as though two particles share a secret, a bond deeper than distance, communicating in a way that laughs in the face of space and time. Einstein hated this idea. He called it spooky action at a distance, certain it must be an illusion. But decades of experiments have shown that the universe is, in fact, quietly spooky beneath the surface. Threads of connection linking particles across unimaginable distances. If you think about it too logically, it feels impossible. But if you relax into it, if you let your mind drift the way one does before sleep, it almost makes sense. The universe doesn't see distance the way we do. It doesn't separate things the way we separate them. It's one continuous fabric, and entanglement is simply the fabric tugging on itself, no matter how stretched it becomes. And you, lying there, breathing softly, are part of that fabric too. Every atom in your body is woven into this same connected tapestry, humming with the same quiet rules that govern distant galaxies and collapsing stars. Another strange but essential idea in quantum physics is the wave function, a mathematical description of all the possible states a particle can be in at once. It's not a physical wave you can see or touch. It's a wave of probabilities, a soft map of maybes. When you don't observe a particle, the wave function lets it drift through all its potential states, all its possible futures. But when you observe it, the wave collapses, and one outcome becomes real. The rest fade away like dreams you forget the moment you open your eyes. For a long time, people thought this meant consciousness must play a role in shaping reality, that the universe waits for a human mind to look at it before making decisions. But that isn't quite right. It's not consciousness that matters. It's interaction. The universe doesn't need a human observer. Any interaction with the environment, even a stray photon, is enough to choose an outcome. Measurement is simply the universe brushing against itself and settling momentarily into a shape we can recognize. Still, it's hard not to feel a little humbled knowing that so much of reality exists only as potential until something nudges it into form. It makes the world feel softer somehow, less rigid, more open to possibility. And perhaps there's something comforting in that, knowing that at the deepest level, nothing is entirely fixed, and even the tiniest particle is always balancing between what it is and what it could be. As you listen, maybe you can imagine the world beneath your fingertips becoming less solid, more fluid, made not of hard material but of patterns and vibrations. and probability clouds. Your pillow, your breath, the air around you. All of it is just atoms dancing to quiet quantum rules. Every object you know is built from particles that were once waves and may become waves again, dissolving and reforming in endless patterns that echo through time. There's a moment when you first step into the quantum world where you might feel a little unsteady, as if the ground beneath your thoughts isn't quite solid anymore. And that's okay. It's part of the charm. Classical physics gives you answers that feel firm and familiar. Quantum physics asks you to loosen your grip a little, to let go of the need for everything to behave the way you expect. It invites you into a different mindset, one that's more about noticing, wondering, and accepting that the universe doesn't owe us simplicity. You might even feel a strange kind of peace in that, like letting yourself float on your back in a quiet lake, trusting the water to hold you up. One of the most enchanting ideas in quantum physics is superposition. The notion that a particle can exist in multiple states at once. It's unsettling when you first hear it, but also strangely beautiful. Imagine a tiny particle not choosing one path, but exploring all possible paths like a traveler too curious to settle on a single road. Before you measure it, it's everywhere it could be, gently shimmering through possibilities. And then, when you finally look, it picks one outcome, not because it was hiding in that state all along, but because the act of looking nudged it into a decision. There's something almost emotional about that, like watching someone who doesn't want to be pinned down finally settle for one choice, even though a dozen others were still softly glowing around them. This idea is captured most famously in Schrödinger's cat thought experiment. A cat sealed in a box with a quantum-triggered mechanism is, in the logic of quantum mechanics, both alive and dead until the box is opened. People like to joke about the cat, imagining it half purring and half ghostly, but the heart of the idea is deeper than that. It's about the uneasy boundary between the quantum world and the everyday world. It's about how weirdness, that makes perfect sense at the particle level, becomes absurd when applied to something we care about, something warm and alive. And maybe that discomfort is the point. It's the universe's way of telling us that our intuition, shaped by apples falling and planets orbiting, isn't built for the tiny flicker of reality beneath it all. If you sit with this for a moment, you might feel a soft, gentle sense of awe. The thought that even the simplest particle holds multiple futures, and that the universe quietly chooses one each time anything interacts with anything else. It gives reality a sense of delicacy, almost like it's handcrafted moment by moment. That's what makes quantum physics feel strangely emotional. It doesn't just describe matter. It describes the very way reality unfolds, how possibility becomes presence, how maybes become moments. Then there's something even stranger, wave-particle duality. The fact that particles, tiny specks you'd swear behave like little dots, can also act like waves, spreading out, interfering, overlapping, as if reality itself forgets its own shape and becomes fluid. Think of how water ripples across a pond when a leaf lands on it. Now imagine that same ripple coming from a single particle, a single photon, as if it stretches itself thin across space and explores every path at once. And the particle isn't doing this because it's confused. It's doing it because that's simply what it is. It's both things at once, and neither fully, until something interacts with it. There's a tenderness in that ambiguity, in the way the universe allows its building blocks to be more than one thing, until the moment they are asked to be one. This blurring of behavior led to one of the most important discoveries in physics, the double-slit experiment. When particles pass through two slits without being observed, they create an interference pattern, like waves crashing into each other. But when you observe them, when you simply ask the universe, which slit did you go through, the pattern collapses and the particles behave like little marbles instead. It's as if the universe blushes when watched, shifting its behavior under the gentle pressure of being noticed. The emotional weight of that is subtle but undeniable. The idea that observation changes reality isn't just fascinating, it's humbling. And maybe that's why quantum physics feels so comforting late at night, when the room is quiet and the only thing you hear is your own breathing. The thought that the universe is built from things that can be here and there, particle and wave, certain and uncertain, all at the same time. It softens something inside you. It reminds you that you don't have to have everything figured out. You don't have to pick a single path right away. You can be a little unsure, a little in between, a little quantum in your own existence. And that's not a flaw. It's part of being alive. One of the most quietly astonishing ideas in all of quantum physics is entanglement, a phenomenon so strange that even the people who discovered it spent years arguing about what it meant. Entanglement is what happens when two particles become connected in such a deep, intimate way that measuring one instantly tells you something about the other, no matter how far apart they are. You could place one particle here beside you and send the other across the galaxy. And still, the moment you look at the first one, the second will settle into a matching state. It's not a message. It's not a signal. It's not even communication in any normal sense of the word. It's simply the universe behaving as if distance doesn't matter, as if the fabric of reality is woven tighter than our senses can perceive. When you hear about it the first time, it feels impossible, almost emotional, like hearing that two friends, separated by oceans, can still feel each other's heartbeat. Einstein hated this. He called it spooky action at a distance. shaking his head at the idea that particles could stay connected across light years. But experiment after experiment has confirmed it. The universe doesn't treat separated things as fully separate. At its deepest level, everything is still quietly linked. The more you think about entanglement, the more you feel the ground shift under your understanding of reality. We like to believe that things exist independently. This object here, that object over there, each with its own location, its own history, its own boundaries. But entanglement whispers that the universe doesn't draw lines where we do. It doesn't put up fences between particles or between moments in time. It lets things overlap, blend, merge, and share information in ways that feel more like softness than separation. And maybe there's something comforting in that. It suggests that nothing is ever truly alone. Even at the smallest scales of existence, connection is the rule, not the exception. This connectedness leads naturally into the idea of wave functions, those mathematical descriptions that tell you all the possible states a particle could be in. A wave function isn't a physical object you can touch. It's more like a whisper of information, a soft haze of potential outcomes. Before you observe a particle, the wave function spreads out, allowing it to hover in many states at once. After you observe it, the wave function collapses, narrowing down all those possibilities to a single realized moment. Some people find this unsettling. The thought that reality waits to decide until the last possible instant. But others find it strangely comforting. There's a gentleness in the idea that the universe doesn't force a particle into a single state until it absolutely has to, that it lets every possibility exist peacefully, side by side, until the moment of interaction. It's like watching a dancer pause with infinite choices before settling gracefully into a single movement. What makes all of this even more beautiful is the idea that observation doesn't have to come from a human. It doesn't require consciousness or intention or even awareness. The universe interacts with itself constantly. Photons bounce, atoms collide, fields ripple. Every interaction is a kind of measurement, a moment where the swirling sea of possibilities becomes something definite. You don't need a scientist in a lab to collapse a wave function. A stray particle of light brushing against an atom will do it just fine. Reality is always smoothing itself out wherever things touch. And yet, despite all this, there's still a profound tenderness in the way the quantum world behaves. Particles exist in soft, overlapping states, only choosing when they must. Connections persist across unimaginable distances, linking things that seem separate. Randomness plays a role not as chaos, but as a quiet generator of variety, ensuring that no two events are ever perfectly identical. If classical physics is the world of firm rules and solid objects, quantum physics is the world of fluidity, flexibility, and delicate possibilities. It feels almost emotional because it resembles something familiar. The way thoughts drift before sleep, the way feelings can overlap, the way memories can exist in many forms until we focus on one. You can imagine decoherence as a kind of gentle softening, a quiet transition from uncertainty to certainty. In your everyday life, you don't see superpositions because they happen too quickly and at scales too large. By the time anything reaches your senses, decoherence has already pinned it into place. But deep down, beneath the surface of the world you can touch, the quantum rules are still humming, shaping everything quietly. Your coffee mug isn't in a superposition when you reach for it, but the atoms inside it still dance to quantum rhythms. The classical world is like a calm lake, smooth and steady, but beneath it is an ocean of quantum ripples. One of the most astonishing ideas in quantum physics, one so gentle and yet so disruptive, is the notion that a particle doesn't simply choose a path. It explores every possible path at once, not metaphorically, not symbolically, but literally in the mathematics that describes it. This idea lies at the heart of Richard Feynman's path integral formulation, a quiet masterpiece disguised behind playful diagrams and scribbles. According to this picture, a particle doesn't travel from point A to point B along a single clean line. Instead, it takes all paths, straight ones, looping ones, zigzagging ones, paths that wander miles out of the way and fold back in on themselves. Every one of these possibilities contributes a tiny whisper of probability. And when all of those whispers combine, most cancel out, leaving behind only the paths that look familiar and classical. It sounds chaotic, but the result is astonishingly orderly, like a million voices singing slightly off key until they merge into a single, perfect note. The beauty of this idea is that it paints reality as something richer than what we see. When you drop a pebble and watch it fall, you're only witnessing the final sum, the quiet agreement reached after the universe has considered every option. The pebble's actual path looks simple, but underneath it is a tapestry of potential journeys woven together. There's something almost emotional about that. The idea that even simple events arise from a cloud of possibilities. That everything we see is the visible tip of a shimmering quantum story beneath. That reality is not rigid, but the result of a negotiation between countless maybes. And though the mathematics can be complicated, the feeling of it is surprisingly soft, like knowing every step you take could have been a dozen other steps, and yet here you are, following the path that emerged from all the others. This brings us naturally to the famous delayed choice experiments, where particles seem to adjust their behavior based on events that haven't happened yet. In these experiments, a particle passes through a setup, a pair of slits or a maze of mirrors, and after it has already begun its journey, the experimenter decides whether to observe it as a particle or let it behave like a wave. And somehow, impossibly, the particle responds as if it had known what was coming. It creates an interference pattern if you choose not to observe which path it took, and it creates two simple clusters of hits if you decide to measure its path, even if that choice is delayed until after the particle has passed the slits. It feels like a little tickle against our understanding of time, a whisper that the past isn't as fixed as we want it to be. Not that the past changes, but that the universe doesn't finalize it until the very last moment. Then there's the quantum eraser experiment, which takes this weirdness and folds it back in on itself. Here, particles are marked with information that could reveal their path. This marking destroys the interference pattern, but the twist is that you can later erase that information, even after the particle has already hit the detector. And somehow, by removing the possibility of knowing which path it took, the interference pattern returns retroactively. It's like the universe holds its breath, waiting to see what you will do with the information, and only then decides how the particle should behave. It doesn't act as though time flows from past to future in a straight line. Instead, it acts as though the outcome is determined by the overall configuration of the experiment, the whole story at once, not by the order in which events appear to us. It's enough to make your mind lean back a little and exhale. These experiments don't let us send messages into the past. They don't break causality or violate logic, but they do remind us that our everyday understanding of time is, at best, incomplete, that the quantum world is not a chain of events marching forward, but a whole structure where relationships matter more than sequence. When you look closely, the universe starts to feel less like a timeline and more like a tapestry woven from both directions, a place where possibilities meet, overlap, and resolve into outcomes only when the entire picture is known, a place where the edges of time feel softer, more fluid, more open. And in the middle of all this strangeness, there is something deeply peaceful, because the quantum world doesn't demand certainty from you. It doesn't insist that you understand it completely. It simply invites you to sit with the wonder, to breathe with the idea that reality can be both wave and particle, both here and everywhere, both decided and undecided, to rest in the notion that you, too, are made from these same patterns, particles that dance through possibilities, atoms woven from uncertainties, that within your body lies the same quiet strangeness that governs the cosmos. There's a moment when you sit with quantum physics long enough where you begin to feel that the randomness woven into the fabric of the universe isn't chaotic at all. It's gentle, almost thoughtful. At the smallest scales, particles don't behave like little machines grinding along predictable tracks. They behave more like flickers of intention, like possibilities softly shivering in place, waiting for their moment to take shape. When we say that a particle's behavior is probabilistic, what we really mean is that the universe prefers flexibility over rigidity. It leaves space for variation, for uncertainty, for a kind of cosmic improvisation. And strangely, the more you think about that, the more comforting it becomes. A determined universe, a perfectly predictable one, would feel cold and mechanical. But our universe breathes. It wiggles. It allows for surprises. It allows for individuality at every scale, from electrons to galaxies. And somehow, that makes reality feel more alive. Randomness in quantum mechanics is not the randomness of a dice thrown recklessly across a table. It is a structured kind of uncertainty, one that follows precise mathematical curves and beautifully symmetric rules. Every possible outcome has its own weight, its own likelihood, its own quiet presence in the wave function. When a particle is measured and chooses one of those outcomes, it's not acting out of chaos. It's acting out of a deeply balanced set of probabilities. There is order in the unpredictability, rhythm in the fluctuations, a hidden geometry behind every quantum jump. You might even say, gently, softly, that randomness is the universe's way of keeping the story interesting. A little looseness in the weave, a little breath between the stitches. This randomness also plays a role in some of the most important processes in nature. In stars, quantum tunneling, the ability of particles to slip through barriers they shouldn't be able to cross, allows nuclear fusion to occur at temperatures far lower than classical physics would predict. Without tunneling, the sun would be cold and dark. The warmth on your skin, the light that grows your food, the glow that lifts your mood on a summer morning, all of it depends on quantum uncertainty. Even the chemistry of life relies on tiny, unpredictable wiggles in molecular behavior. Mutations happen because particles don't always behave the same way twice, and those mutations make evolution possible, meaning that every tree, every bird, every person, every moment of consciousness is shaped by randomness, not a wild, destructive randomness, but a gentle nudge here and there, a deviation that allows life to change, explore, and flourish. And when you trace that idea inward, something softens, because it means you, sitting or lying wherever you are right now, are the result of a universe that isn't rigid, a universe that allowed for the possibility of you. If the quantum world were completely deterministic, every atom, every chemical reaction, every moment in history would have been locked into place from the very beginning. But because randomness exists, new branches of possibility continually unfold. Every moment holds a little room for the unexpected. Every life is a tiny miracle of maybes collapsing into something real. In this way, quantum mechanics isn't just a theory of particles, it's a theory of potential. It's a reminder that the world is not a script already written, but a story still taking shape, moment by moment, interaction by interaction. And there's something deeply human about that. We live our lives in a similar balance. Plans and probabilities, hopes and uncertainties, choices and chance. Some things are predictable. Many things are not. We navigate our days the way particles navigate their possibilities, drifting until we decide, deciding until we drift again. Even the act of measurement, that mysterious collapse of the wave function, begins to feel less like a mathematical trick and more like a metaphor for attention. When a particle is unobserved, its wave function spreads, a cloud of options. When it's measured, that cloud tightens into one clear result. In our own lives, when we focus on something, a goal, a feeling, a memory, it becomes sharper, more solid. And when we let our attention relax, everything widens again into possibility. The universe, it seems, is doing something similar all the time, at every level, a constant dance between what is and what could be. And maybe that's why quantum physics pairs so well with sleep. As you relax, as your thoughts spread out and soften, as your awareness drifts between dreams and waking, your mind starts to behave a little like the quantum world, slipping between states, holding multiple possibilities at once, gently collapsing into one only when you're ready. It's not chaos. It's not confusion. It's the natural ebb and flow of consciousness, mirroring the ebb and flow of particles around us. When you think of it that way, the universe feels less like a machine and more like a living poem, not rigid, but fluid, not absolute, but shimmering at the edges, a place where uncertainty isn't a flaw, but a feature, a doorway to creativity, complexity, and change. And that thought, soft and quiet, settles over you like a blanket. When people first learn about the quantum world, they often imagine it as something distant and miniature, a realm tucked far below our senses, irrelevant to the scale of ordinary life. But the more you explore it, the more you realize that the quantum world isn't beneath reality. It is reality. Everything you see, everything you touch, everything you feel is built from the same delicate rules. Atoms hold together because electrons settle into quantized energy levels, like soft musical notes that can only be played at certain frequencies. Molecules bond because quantum waves overlap and intertwine into patterns that classical physics can't begin to describe. Even the warmth in your body is the motion of particles vibrating in quantized steps, little leaps of energy that follow the universe's smallest rhythms. And when you pause and think about that, really think about it, something inside you relaxes, because it means that all the stability you rely on, all the solidity that supports your life, arises from the same strange softness that governs electrons and photons. The world feels firm, but its foundation is gentle. The standard model of particle physics, our best map of the quantum ingredients of reality, is built from these delicate truths. It tells us that everything, from the glow of a candle to the iron in your blood, comes from a family of fundamental particles interacting through a handful of forces. Up quarks, down quarks, electrons, neutrinos, tiny actors in a cosmic play, photons carrying light, gluons holding nuclei together, W and Z bosons guiding radioactive decay, and of course the Higgs boson, the quiet field we all move through, the field that gives particles their mass. You can imagine the Higgs field as a kind of invisible fog spread through all of space, and particles moving through it feel a kind of resistance. Some glide easily, light and swift. Others push against it more strongly and take on mass, becoming heavier and slower. And somehow that simple interaction creates the world we know. Without the Higgs field, there would be no atoms. Without atoms, no chemistry. Without chemistry, no life. It's humbling to think that something so quiet, so subtle, so impossible to detect without enormous machines, is the very thing that lets you breathe, move, exist. And even more humbling is the fact that the standard model, for all its success, leaves so much unexplained. It's like having a beautifully detailed map of a small island while knowing an entire continent lies beyond the shoreline. Dark matter, dark energy, gravity, none of these fit comfortably into the standard model. In fact, when you add up everything we understand, all the particles and forces we can measure, it accounts for only about 5% of the universe. 5%. The rest is made of things we can't see, can't touch, and can barely describe. And yet, those invisible components shape the motion of galaxies, the growth of cosmic structures, the ultimate fate of the cosmos itself. It's as if the universe is gently reminding us to stay humble, to keep listening, to accept that most of its story is still hidden in the shadows. This hiddenness is part of what makes quantum physics feel so dreamlike. It's a science of glimpses, a flash of a particle here, a shift in an energy level there, a faint trace left on a detector screen. We never see the quantum world directly. We see its footprints, little signs that something passed through, something delicate and fleeting. The closest we get to seeing the quantum realm is through mathematics, those swirling symbols and equations that describe the behavior of probability waves. But even that description is incomplete, like trying to photograph a breeze. And yet, these glimpses are enough to build technologies that define modern life. Lasers, MRI machines, semiconductors, GPS, All of them run on quantum rules. You carry quantum physics in your pocket every time you use a smartphone. Your world works because the universe follows these quiet, surprising patterns. And in that sense, the quantum world feels less like a distant mystery and more like a familiar companion, always there, steady and reliable, even if it behaves in ways that defy our intuition. When you flip a light switch, photons respond instantly. When you take a breath, electrons flow through your body, guided by quantum fields. When you fall asleep, your brain hums with electrical patterns shaped by quantum processes in molecules and ions. The strangeness is everywhere, woven into every heartbeat, every thought, every moment of rest. Something about that feels deeply comforting. Knowing that the universe doesn't need to make sense to still hold you gently. Sometimes, late at night, you might even feel a little closer to those mysteries. Maybe because the world is quieter. Maybe because your mind is softer. Maybe because the dark invites wonder in ways daylight never does. Whatever the reason, the thought that reality is built from uncertainty and possibility might feel less intimidating and more reassuring. The universe is not a rigid blueprint. It's a living process, a dance between what is known and what is still unknowable. And all of that strangeness, every whisper of uncertainty, every hidden particle, every improbable interaction, gathers effortlessly into the stable world you know. The chair holding your weight, the air filling your lungs, the softness beneath your head, stability built from uncertainty, solidity built from waves, certainty built from chance. It's almost poetic how the smallest, most unpredictable things can assemble into something so steady and familiar. The universe doesn't hide its magic out of cruelty. It hides it because that's simply how it works, quietly, softly, beneath the surface of things. If you follow the thread of quantum physics deeper, past the particles and the fields and the equations, you eventually reach a question that feels less like science and more like philosophy, whispered into the dark. What is reality made of? For most of history, the answer seemed obvious. Matter, objects, stuff, things with edges and weight and shape. But quantum physics gently brushes that idea aside and replaces it with something softer, something stranger. It tells us that reality is not built from solid pieces at all. Instead, it's built from interactions, little exchanges of energy, tiny moments of contact where particles influence one another. When you strip away everything else, what remains is a universe made of relationships, not things. Nothing exists in isolation. Every particle is defined by how it interacts with the rest. And that realization, surprisingly, feels tender. It means the universe is woven together not by walls, but by connections. This relational nature becomes clearest in quantum field theory, the framework that says particles aren't really little dots bouncing around. They're excitations, tiny ripples in vast fields that stretch across the entire universe. The electron field, the photon field, the quark field, all of them fill every corner of space, even the space you're sitting in right now. When you touch your fingers together, or when a breath rises softly in your chest, those sensations aren't caused by solid objects colliding. They're caused by interactions between fields, subtle forces exchanging tiny packets of energy. The world you feel is the world filtered through quantum fields humming all around you, like invisible currents shaping everything you experience. You are not separate from these fields. Your body is these fields, arranged in a delicate, temporary pattern. And there is something soothing in that thought, that you are both solid and not solid, both local and spread out through the deeper weave of the universe. The vacuum, the so-called empty space between particles, is not empty at all. It's alive with activity, pairs of particles popping in and out of existence, fluctuation shimmering like heat on a summer road, energy rising and falling in tiny ephemeral waves. Even in the quietest darkness, the universe is buzzing. That restless motion might sound chaotic, but it's not. It's balanced, controlled, soft. A constant dance of energies that allows forces to exist, that lets atoms remain stable, that keeps the cosmos breathing in its own subtle way. If you could somehow shrink yourself down and stand inside a single cubic centimeter of vacuum, it wouldn't feel still. It would feel like standing inside a whispering ocean of invisible energy, and yet that ocean holds you together, holds the world together, effortlessly, without needing to be understood. What's astonishing is how much of our world emerges from this whispering chaos. The very stability of matter, the fact that atoms don't simply collapse or fly apart, comes from quantum motions so tiny and rapid we can't directly observe them. Electrons dance in orbitals, existing not in neat circular paths, but in diffuse clouds of probability, shaped by wave functions that look like shells, teardrops, and strange, swirling knots. These shapes aren't artistic interpretations. They're real mathematical structures that define how atoms bond, how light is absorbed, how life grows. The warmth of a flame, the color of a leaf, the way your body processes oxygen. All of it comes from electrons shifting between quantized energy levels, releasing or absorbing photons as they settle into new configurations. The familiar world is built from transitions, from jumps, from flickers of light, too small and too fast for the eye to see. It's also built from uncertainty, not the stressful kind, but a quiet, intrinsic uncertainty. a softness in the universe's handwriting. The Heisenberg uncertainty principle tells us that some pairs of properties, like position and momentum, can never be known with perfect precision at the same time. The more clearly you see one, the blurrier the other becomes. This isn't a limitation of our instruments or our intelligence. It's a fundamental feature of nature. And when you think about it for a moment, it feels strangely appropriate. Nothing in life is perfectly pinned down. Thoughts drift. Emotions shift. The future wavers. Certainty is always a little out of reach, not because we're failing, but because the world itself is written in probabilities. The quantum universe mirrors our own internal universe more elegantly than we ever expected. Even time, which we treat as a steady flow, becomes more mysterious under quantum light. At small scales, processes don't always unfold in the neat order we expect. Causes and effects blur. Events can seem to influence one another in ways that are not confined by classical time sequences. And yet, despite this deep weirdness, the macroscopic world, the world you live in, remains comfortably predictable. Days still pass. Mornings still follow nights. Your heart still beats in steady rhythm. The strangeness below the surface doesn't disrupt the stability above it. It supports it. And maybe that's what makes quantum physics feel dreamlike. The way it so gently contradicts our assumptions while still holding the world together. You're living in a universe that is both solid and not solid, both predictable and uncertain, both classical and quantum. A universe that behaves one way when you look closely, and another when you look from far away. A universe that doesn't collapse under its contradictions, but thrives because of them. A universe that is, in every sense, softer than it seems. When physicists began trying to make sense of this strange new world beneath the surface of matter, they discovered something unexpected. That the mathematics guiding quantum reality doesn't behave like our everyday logic. It bends. It folds. It allows things to exist in states that seem impossible until you give them room to breathe. One of the most beautiful examples of this is the concept of the wave function, that soft mathematical cloud that describes all the possible states a particle can occupy. The wave function isn't a physical object, but it shapes physical outcomes. It tells you where a particle might be, how it might move, what it might do next. And the moment you measure the particle, the wave function collapses, settling into a single outcome with a kind of quiet finality. It's as if the universe offers you a bouquet of possibilities, then gently chooses one the instant you look. But this collapse raises deeper questions. Questions physicists still whisper about in late-night labs and coffee shops. What exactly makes the wave function collapse? Why this outcome and not another? Is the observer truly a participant in the unfolding of reality?
perhaps just an illusion, a mathematical trick played by deeper hidden variables we haven't discovered yet. Some interpretations say the observer matters. Others say everything is deterministic underneath. But the gentlest view, the one that feels right when you're drifting towards sleep, is that the universe doesn't separate us from itself as sharply as we think. That observation isn't an intrusion, it's a conversation, a meeting point, a moment of contact where the universe becomes aware of one tiny part of itself through you.
As you drift deeper into this quantum landscape, the boundary between science and softness becomes almost impossible to feel. The theories that once seemed cold or abstract begin to take on a kind of quiet humanity. You start to see how the same principles shaping atoms also shape the flow of your own life. For example, think about quantum fluctuations, those tiny, unpredictable tremors in the vacuum that give rise to everything from the structure of galaxies to the spark of chemical reactions in your body. Without fluctuations, nothing new would ever happen. No stars would ignite. No atoms would bind. No thoughts would flicker in your mind. Every moment of novelty, every shift, every transformation, all of it rests on the universe's willingness to wiggle just a little. And maybe that's a soft reminder that change, even when it feels unsettling, is woven into the very structure of existence. You don't have to be perfectly steady to be whole. There's something similar in the way electrons form clouds rather than orbits. They don't follow neat circular paths the way early scientists imagined. Instead, they inhabit regions, fuzzy, probabilistic shapes where they are more likely to be found. And it's those shapes, those orbitals, that determine how atoms bond, how molecules form, how chemistry happens. If electrons had strict predictable paths, the richness of matter would disappear. No colors, no smells, no complexity, no life. So the next time you feel uncertain or blurry inside, maybe you can think of electrons drifting through their clouds and know that uncertainty doesn't mean failure. Sometimes uncertainty is what allows beauty to take shape. And then there's entanglement again, that quiet, intimate connection stretching across distance. One of the most surprising things about entanglement is how effortlessly it happens. Particles become entangled simply by interacting. They touch, and something in their shared history becomes permanent. Even when they drift apart, the memory of that contact stays woven into their states. There's something deeply human in that. People touch each other's lives in small ways. A kind glance, a shared laugh, a conversation that arrives at exactly the right moment, and those moments ripple forward. You may not see the person again, just as entangled particles may never meet again, but the impact remains. A part of you carries the trace of that interaction. Something changed because of it. Something subtle, maybe, but real. Quantum physics is full of moments like that. ideas that begin as technical descriptions but bloom into reflections of the way everything is connected. Even decoherence, the process that makes the quantum world fade into the classical one, feels almost like a metaphor. When a quantum system interacts with its environment, its delicate superpositions disappear into the noise of the world. Not gone, exactly. Just hidden. And that's not so different from how certain possibilities in life quietly slip away as you grow older, as you make choices, as you become more entangled with the world around you. You don't lose those possibilities because you did something wrong. You simply become a person with a history instead of a person made of pure potential, and that's okay. It's natural. It's the way coherence gives way to clarity. There's also the matter of time, that steady current we feel so sure is moving forward. But in quantum physics, time becomes strange. At very small scales, the distinction between past and future blurs. Events can influence one another in ways that challenge our intuitions. Causes and effects sometimes lose their direction. Even the equations that govern particle behavior are symmetric in time. They work just as well forward as backward. The arrow of time, the way you remember yesterday but not tomorrow, the way a cup can shatter but never unshatter, doesn't come from fundamental laws. It comes from entropy, from complexity, from the way information spreads and disperses. And there's something comforting in that too, because it means the flow of time isn't a rigid command. It's a gentle drift, a direction chosen not by the universe's machinery, but by the way patterns unfold. And of course, the quantum world has space for randomness. True randomness, not the messy kind that comes from ignorance or error, but a fundamental softness in the fabric of reality. A particle decays not because something forces it to, but because probability nudges it at the right moment. A photon chooses one path instead of another not because of hidden gears or unseen mechanisms, but because the universe allows a degree of spontaneity. In a way, randomness is a reminder that not everything needs an explanation. Not every moment in your life needs a reason. Some things happen simply because they do. And sometimes, those things turn out to be exactly what you needed. As your body grows heavier and your thoughts drift slower, you might notice how all these ideas, uncertainty, connection, emergence, time, randomness, begin to blur into a single, gentle feeling. A sense that the universe isn't rigid or unforgiving. It's soft around the edges, flexible, capable of holding contradictions with grace, capable of letting patterns grow from chaos, capable of letting you exist exactly as you are. A temporary arrangement of stardust and quantum fields, breathing quietly in the dark. There's a thought that often drifts into the minds of physicists when they're alone in their offices late at night, staring at chalkboards filled with symbols and diagrams. A thought that is never written into the equations, but always lingers behind them. How does something so small create something so vast?
How do the tiniest rules of quantum mechanics give rise to the complexity of galaxies, planets, oceans, forests, and the person lying here listening right now? It feels almost impossible that randomness and probability at microscopic scales could produce anything coherent, let alone a universe with structure and meaning. And yet, that is exactly what happens. The world doesn't emerge from certainty. It emerges from patterns rising out of uncertainty, like melodies rising from the soft noise of a distant radio. This phenomenon, emergence, is one of the quiet triumphs of nature. You see it everywhere once you know how to look. Individual water molecules are chaotic, each one moving unpredictably, bouncing, vibrating, colliding, and yet together they create waves that roll across the ocean, snowflakes that form with perfect symmetry, raindrops that cling to leaves. Individual neurons fire randomly, jittering with electrical noise, and yet from that chaos arises a thought, a memory, a sense of self. Even your heartbeat, steady and rhythmic, emerges from a network of cells that each beat with slight imperfections. The order you experience in your life is not the opposite of chaos. It's built from it. The universe doesn't eliminate randomness. It organizes around it. This is part of why quantum physics feels so strangely comforting. It's a reminder that order doesn't require perfection, that beauty doesn't require certainty, that stability doesn't require stillness. The atoms in your body, the thoughts passing gently through your mind, none of them are perfectly predictable or perfectly quiet. And still, here you are, whole and complete in a way that transcends those flickering foundations. The world is not a machine made of rigid, interlocking gears. It's a dance made of shifting rhythms. And because of that, it's able to adapt, to change, to grow. You are not a fixed object. You're a living process, constantly emerging from the quantum hum of your own biology.
One of the most beautiful examples of emergence in the quantum world is superconductivity, the way certain materials can carry electricity with absolutely zero resistance when cooled to extremely low temperatures. On their own, electrons repel each other. They move chaotically, scattering and bumping and losing energy. But under just the right conditions, they pair up into what are called Cooper pairs, flowing through a material in perfect coordination. A kind of quantum harmony emerges from a system that once looked noisy and disordered. Resistance vanishes. The electrical current becomes smooth, endless, frictionless. It's like watching a crowd of people suddenly break into synchronized dance without a single word exchanged. This happens because quantum mechanics allows the system to settle into a lower energy state where cooperation is favored over chaos. And there's something deeply peaceful in that. The idea that even at the smallest scales, harmony can arise unforced, that order can arise naturally when conditions are right, that sometimes things flow more smoothly when we soften instead of tighten, when we cool instead of burn. In a way, superconductivity is a reminder that ease is possible, not by forcing the world into order, but by letting the system find its own gentler state. Then there's quantum indistinguishability, the fact that identical particles of the same type aren't just similar. They are fundamentally indistinguishable. Every electron in the universe is exactly the same as every other electron. Not similar, not close, identical in every measurable way. If you swap two electrons, nothing changes. The universe doesn't even notice. And because of that, particles follow rules of collective behavior that allow them to act in ways that classical objects never could. The individuality we take for granted at the human scale dissolves at the quantum scale. Identity becomes a shared property, not an isolated one. When you think about that long enough, it starts to feel strangely comforting. Not in a way that diminishes your uniqueness, but in a way that connects you to everything else. The electrons in your body could trade places with electrons in the heart of a distant star, and the universe wouldn't blink. There are parts of you, deep, fundamental parts, that are literally the same as the parts of everything else. The world feels big, overwhelming, full of separation and distance. But beneath the surface, there is sameness. There is unity. There is a kind of quiet belonging written into the fabric of existence. And as your thoughts begin to slow, as your breath becomes deeper and softer, these ideas settle into something more like feelings. You might feel a sense of spaciousness, as if the walls around you have softened. You might feel a sense of connection, as if the world is not a distant place, but something you're gently held within. You might feel a sense of permission to be uncertain, to be in motion, to be a work in progress. Because everything in the universe, from the smallest particle to the largest structure, is also a work in progress. A ripple, a possibility, a moment in a much larger story. There's a gentleness hidden in the quantum world that most people never hear about. We tend to focus on the dramatic parts, the uncertainty, the tunneling, the entanglement, the strange, almost rebellious behaviors that feel like the universe is breaking its own rules. But beneath all that, there's another layer, one that feels softer, more intimate. It's the layer where particles don't just collide or repel each other, they listen to one another. They adapt to each other. They settle into patterns that minimize conflict, conserve energy, and create balance. It's almost as if every particle is quietly trying to live with as little friction as possible, responding to its neighbors in a way that keeps the system calm. This is what physicists sometimes call the principle of least action, a guiding rule of nature that says, among all the paths a particle could take, it follows the one that requires the least effort. The path that's smoothest, simplest, gently curved rather than sharply forced. This principle shows up everywhere. A beam of light always chooses the path that takes the least time. A falling object moves in a way that minimizes wasted energy. Even the orbit of a planet is a kind of cosmic relaxation, the path where gravity and motion balance perfectly. At the deepest level, the universe doesn't struggle. It seeks the quietest path available. There's something comforting about that, isn't there? This idea that nature itself prefers ease, that it leans toward the softest edges, the gentlest bends, the most harmonious routes. And if you listen closely enough, you might feel that same principle reflected in your own life. The moments where you've tried to force things, to push too hard, to control every outcome, those moments often end in exhaustion. But when you allow yourself to soften, when you move toward what feels natural instead of what feels forced, life tends to flow more easily. Not because everything becomes perfect, but because you stop wrestling with the currents. You follow the least resistant path, just like a photon gliding through a crystal. Some physicists like to say that the universe optimizes itself, not in a conscious way, but in a quiet, mathematical way that makes everything a little smoother, a little simpler, a little more elegant. And you can feel that elegance in the quantum rules that govern the world. The way electrons fall into discrete energy levels, not because they refuse to exist in between, but because the allowed states are the ones that minimize the system's energy. The way atoms bond in shapes that reflect the most stable, most balanced configurations. The way entire molecules fold into intricate, beautiful structures that are simply the easiest for them to maintain. Even your DNA, the blueprint of your entire body, twists into its iconic double helix because that spiral shape allows it to store the most information with the least strain. Life itself began by following the simplest path that allowed it to persist, not by brute force, but by graceful adaptation. You are, in every sense, a structure shaped by the universe's desire for balance. And as you breathe softly now, feeling your chest rise and fall in its own natural rhythm, you can sense that same principle moving through you. Nothing forced, nothing rigid, just a slow settling into the shape that requires the least effort. The shape that lets you rest. Your muscles don't need to hold tension right now. Your thoughts don't need to strain for answers. You're allowed to take the path of least action, the path that feels like lying back into a warm, welcoming field of stillness. There is another idea from quantum physics that feels especially gentle in moments like this. The concept of ground state. Every system has one.
the lowest energy configuration it naturally settles into when all disturbances fade away. In highly excited states, particles jitter, fluctuate, radiate energy. But when they relax, when the noise quiets, they drift downward into the calmest state available to them. Not because they're forced to, but because resting is what they were built to do.
You too have these states. The version of you that exists when worry quiets, when pressure lifts, when no one needs anything from you, when you're allowed to simply be. You can feel yourself drifting there now, slowly, gently, like a particle cooling into its most peaceful configuration. There's nothing you need to achieve in this moment, nothing to analyze, nothing to prove, just a soft return to your own ground state, where everything settles into place without effort. Quantum mechanics often sounds chaotic, but at its heart, it is full of patterns, repeating symmetries, quiet consistencies, gentle limit points that emerge out of the seeming randomness. And maybe that is part of why it resonates so deeply with us. We spend so much time trying to understand life, to control it, to predict it. But sometimes the most honest thing we can do is step back and let the deeper patterns take over. Let them guide us the way they guide particles, the way they guide light, the way they guide entire galaxies. There's a moment when you're falling asleep where the world feels like it's drifting away at the edges. Sounds soften, shapes lose their sharpness, thoughts spill into one another, blending into something both familiar and strange. And in that drifting state, the boundaries that usually feel so solid between you and the world, between thought and dream, between now and later, begin to blur. Quantum physics lives in that kind of space all the time, a space where sharpness isn't necessary, where possibilities are allowed to overlap, where the universe doesn't demand certainty, only presence. Sometimes I wonder if that's why thinking about quantum mechanics feels so soothing late at night, because the mind itself becomes a little quantum, a little fuzzy, a little open to possibilities it wouldn't consider in the daylight. One of the most beautiful concepts in quantum theory is the wave function, not because of the mathematics behind it, but because of what it represents. A wave function is a description of everything that could happen, every possible location a particle might appear, every energy it might have, every path it might take. It's not a single outcome, but a cloud of potential, softly surrounding the particle like an aura of maybes. Before measurement collapses it, the wave function holds all possibilities at once, not in conflict, but in harmony, like layers of a chord played so gently that they merge into one shimmering sound. Sometimes, when you're lying in bed and your mind drifts from one possibility to another, imagining tomorrow or remembering yesterday or wondering about things that might never happen, it feels a bit like your own wave function. You're not committed to any one thought. You're just floating among potentials, letting them wash through you without needing
often described as sudden and dramatic, a particle snapping into place when observed, but in reality, it's a much gentler process. It's more like settling, like a leaf drifting through the air and eventually finding the ground. The probabilities shift. The environment interacts. Information trickles in, and slowly the system narrows itself into a single outcome. And there's something comforting in that too. The idea that decisions in your life don't always come from grand, decisive moments. Sometimes they come from subtle shifts, a quiet realization, a soft change of heart, a feeling that guides you more than logic does. You collapse possibilities the same way particles do, slowly, naturally, without pressure. There's also a strange tenderness in the idea that particles don't have defined paths. They don't walk clear trajectories through space. Instead, they leave behind patterns, suggestions, footprints of probability. When you look back on your life, you see something similar. You don't remember every step you took, every breath you breathed, every moment you lived. You remember flashes, certain details, emotional snapshots. Your life doesn't feel like a straight line. It feels like a collection of meaningful points connected by threads you weave in hindsight. The universe works the same way at the smallest scales. It doesn't track every detail. It only reveals what is necessary when you ask.
And then there's the vacuum, that empty space that isn't empty at all. The vacuum seethes with virtual particles appearing and disappearing too quickly to be measured directly, borrowing energy from the universe and returning it in the tiniest flickers. Even nothingness is full of activity, full of potential, full of invisible motion. When you pause at night, when everything feels still, when the world seems quiet and motionless, you're actually surrounded by a universe that is bursting with invisible life. The silence is filled with motion. The emptiness is filled with possibility. And maybe that's a reminder that even when you feel still inside or empty inside, you're not truly either of those things. There is always a quiet movement in you. Thoughts forming, emotions shifting, cells dividing, neurons sparking. Your stillness is alive. Some quantum theorists talk about the idea that the entire universe is fundamentally information, not matter, not energy, but the relationships that describe them. Every particle, every interaction, every force is defined by the information it carries, where it could be, how it behaves, what it influences. And if you stretch that idea just a little, it starts to feel like something familiar. You're shaped not just by your body or your biology, but by information, your memories, your experiences, the stories you've lived. You're a network of relationships too, a pattern that exists in the people who know you, the thoughts you've shared, the moments that changed you. In a very real sense, you continue existing in their minds long after the moment has passed. Just like particles leave ripples in the fields around them, everything in the quantum world is relational, and everything in human life is too. Nothing exists alone, not galaxies, not atoms, not people. You are connected to the world in ways you can't always see, through memories, through influence, through the simple fact of being alive in a universe where every particle interacts with every other. The edges of you are not as sharp as they seem. There's a quiet question that sits at the edge of quantum physics, one that scientists rarely ask out loud, not because it's unscientific, but because it feels almost too intimate, too close to the core of experience. What does it mean to observe something? In everyday life, to observe means to look at something, notice it, pay attention. But in quantum mechanics, observation isn't just seeing, it's participation, it's interaction. It's becoming part of the system in a way that changes it. And when you think about it long enough, that idea begins to touch something very human. Because every time you pay attention to something in your life, you change it too. A feeling ignored grows heavy. A feeling acknowledged softens. A memory you revisit becomes clearer. A memory you avoid fades. Attention is not passive. It reshapes the world inside you. One of the most intriguing ideas in quantum theory is that a particle's properties are not definite until measured. Before observation, you cannot say where a particle is. You cannot say what direction it spins. You cannot even say whether it has a specific value for the property you're trying to measure. It lives instead in a haze of potential. And yet, that haze is not meaningless. It is rich. It contains all the possibilities that the particle might become. Only when you interact with it, when you shine light on it, when you set up a detector, when you decide what you want to know, does the particle choose a definite state. This is not because your mind forces it to choose, but because your interaction gives it a context in which the universe must respond. And in a quiet way, your own inner life works like this too. Before you reflect on a feeling, it exists in a soft, undefined state, a blend of emotions, impulses, memories, and sensations. But the moment you turn toward it with awareness, the moment you name it, feel it, acknowledge it, it becomes something. It takes shape. Not always the shape you expect, but a shape nonetheless. You collapse your own emotional wave functions every time you're brave enough to observe what's happening inside you. Awareness clarifies. Attention crystallizes. Even if it hurts at first, the act of noticing is the first step toward understanding. There's a beautiful idea in certain interpretations of quantum mechanics called participatory reality. The notion that the universe isn't a fixed stage, but a kind of ongoing conversation, a call and response between what exists and what is observed. It doesn't mean consciousness creates reality, but it does mean that reality is not fully expressed until interactions bring it to light. The world is not a picture painted long ago. It's a painting still being brushed into existence, stroke by stroke, interaction by interaction. And you, simply by being alive, are part of that process. Every breath you take is an interaction. Every photon that strikes your retina becomes part of your story. Every moment of awareness ripples quietly into the fields around you. And when you think about consciousness, that delicate phenomenon that arises from neurons firing in patterns far too intricate for us to fully understand, it begins to feel almost like a quantum question itself. Your brain is built from particles that obey quantum laws. Your thoughts emerge from electrical pulses that interact with the quantum behavior of ions and electrons. You're made from the same fields that ripple through the vacuum. And while consciousness is far from being explained by quantum mechanics, the connection is undeniable in one way. Both are rooted in mystery. Both hum quietly behind the curtain of what's observable. Both remind us that the surface of reality, the world we touch and measure and name, is only part of the story. Some researchers have wondered whether quantum effects play a role in the way consciousness forms, not because the mind is magical, but because the brain operates on the edge between order and chaos. Neurons fire in patterns that are stable but not rigid, intricate but not random. Microtubules inside nerve cells might host quantum states that last longer than expected. Synapses flicker with probabilities, not certainties. And while none of this means consciousness is a quantum wave function, it does suggest that our experience of being alive might echo the universe more deeply than we realize. You are both stable and fluid, both defined and undefined, both a continuity and a collection of fleeting moments stitched together by memory and meaning. And then there's the dreamlike thought that every observation we make is also an observation of ourselves. When you look at the world is looking back through the changes you cause. When you observe a star, photons that traveled for millions of years end their journey in your eyes. Their final act is to reveal something, both about the star and about you. When you listen to a sound, the vibrations that reach your ears become part of your perception. Observation is a two-way street. You touch the world as it touches you. Quantum physics shows us that the universe is not a fixed, silent place. It's responsive. It's relational. It's alive with possibility. And perhaps the most comforting part is this: you don't need to understand everything to belong here. You don't need to solve the mysteries to be part of them. You are already woven into the fabric of the cosmos simply by existing, by observing, by feeling, by dreaming, by being. Time is one of those things we take for granted, like the feeling of gravity or the softness of breath. It feels linear, solid, steady, a stream you're drifting
physics, time is far stranger, far softer, far less rigid than it feels in daily life. At the quantum scale, particles don't always respect the boundaries we expect. They can borrow energy from the future, slip briefly into states that shouldn't exist, or behave in ways that make the very idea of before and after a little blurry. Even Einstein's equations tell us that time isn't a universal drumbeat. It stretches, bends, slows, and quickens depending on motion and gravity. There is no single cosmic clock. There are only local rhythms woven together. And when you lie here, letting your mind grow quiet, you might notice something surprising. Your experience of time softens too. Minutes stretch, thoughts drift, memories rise without order. The moment you're in becomes larger and calmer, like a tide that moves at its own pace. You feel time not as a strict sequence, but as a gentle accumulation of sensations. That's the closest many of us ever get to experiencing what the universe feels at the quantum level. A place where time is less a ruler and more a suggestion.
Entropy, the tendency for disorder to increase, is often blamed for the arrow of time. But entropy isn't a villain. It's the reason stars shine. It's the reason chemical reactions fuel your cells. It's the reason your warm breath spreads softly into the cool air of your room. Entropy ensures that energy flows from high to low, from organized to dispersed, from tension to relaxation. Without entropy, nothing could settle, nothing could cool, nothing could grow. In a way, entropy is the cosmic sigh that allows the universe to move forward, to release energy, to relax into new forms. You might feel that in your own life too. Those moments where things fall apart a little, where structure dissolves, where old patterns loosen their grip. It can feel frightening, like you're losing control. But often, those are the moments that make room for something new. Entropy isn't destruction, it's transformation. It's the gentle rearrangement of things into shapes they were always meant to take. Without it, no change would ever be possible. You would remain stuck in every moment you've ever lived. The universe would be frozen in its earliest state, a dense, hot silence. Instead, it opened, expanded, cooled, and made space for stars, planets, oceans, and eventually you. Memory, too, is tied to time in ways we rarely consider. Neuroscientists often compare memory to a recording, but that's not really accurate. Memory is reconstructive, not reproductive. Every time you recall something, you build it again. You recreate it, drawing from fragments stored across your brain, sounds, images, feelings, interpretations, and then you weave them together into a cohesive experience. In a very real way, your memories behave like quantum states. They are not fixed objects. They exist as potentials until you observe them, and the act of observing changes them. Memories become softer, reshaped by who you are now, influenced by everything you've felt since the moment they first formed. And maybe that's a good thing. Maybe memory isn't meant to be a perfect record. Maybe it's meant to be a living, breathing part of you, adaptable, forgiving, able to give you comfort or distance when you need it. Just like the wave function collapses into the state most compatible with the context, your memories settle into forms that help you make sense of your life, moment by moment, breath by breath. When you think about existence this way, as something unfolding rather than fixed, emerging rather than predetermined, the universe begins to feel less like a machine and more like a story, a slow, cosmic story written in the language of energy and probability. Every star is a chapter. Every atom is a sentence. Every quantum fluctuation is a comma that changes the rhythm slightly. And you, lying here now, drifting in your own quiet thoughts, are a paragraph written into the fabric of space-time. Not random, not accidental, just part of the flow. Sometimes the most comforting thought of all is this: nothing in the universe is ever truly still. Even in the deepest silence, the fields continue to ripple. Even in the coldest vacuum, particles flicker in and out of existence. Stillness is not the absence of movement. It's the balance of movement, the harmony of countless tiny motions canceling each other out. And that means you don't need to feel perfectly quiet inside to be at peace. You don't need to stop thinking. You don't need to silence every emotion. Peace doesn't mean the absence of activity. It means the gentle settling of everything into a state that feels natural. This is where quantum physics starts to feel oddly human. Because we too exist as bundles of possibility. We too collapse into specific choices only when life asks us to. Most of the time, we're drifting between futures, some likely, some not. And only when the moment arrives do we step into one path and leave the others behind. You can almost feel the parallel. Electrons drifting in probability clouds, people drifting in plans and hopes and fears, both of them shaped by uncertainty, both of them finding clarity only at the moment of action. And just like the quantum world, our lives are influenced by tiny things, brief interactions, small nudges, quiet forces we barely notice. The beat of a heart, the tone of a voice, a single moment that changes everything. In a way, we're all quantum systems, collapsing into ourselves each day. And then there's entanglement. that impossibly intimate connection between particles that can stretch across galaxies. Two particles born together or interacting just once can become linked so deeply that measuring one instantly defines the other, no matter how far apart they drift. Einstein called it spooky action at a distance because it seemed too strange to accept, too fast, too connected. But decades of experiments confirm it's real, not metaphorically real, but physically real. Entanglement exists. The universe is connected in ways that defy classical logic. If two particles can share a state across the cosmos, what does that say about boundaries, about separation, about the idea that space itself divides things? Perhaps the deepest truth is that space doesn't separate objects. It only separates where we see them. In that sense, entanglement feels like the universe showing us its tenderness, a reminder that connection isn't limited by distance or by time or by the edges of our understanding. Particles keep their shared memory no matter how far they travel. They remain part of one story, one relationship, one whisper of correlation stretching quietly across the fabric of space-time. And although entanglement doesn't carry messages or thoughts or emotions, the idea itself carries a kind of emotional resonance, because we too form bonds that distance can't fully erase, connections that remain even across years and continents, a shared past that still shapes us, even when the people involved are long gone or far away. Entanglement is not a metaphor for human connection, but it's hard not to feel the echo of it, soft and familiar. Even the vacuum, that restless sea of virtual particles, seems to participate in this cosmic intimacy. It lets forces propagate. It lets fields ripple. It lets particles interact and exchange momentum in ways that would feel impossible in a truly empty void. The vacuum is like the quiet breath beneath the universe's heartbeat. You never hear it. You never feel it. But without it, nothing would move, or bind, or shine. And that's the beauty of the quantum world. It thrives in silence. It thrives in whispers. It thrives in the margins we overlook when we're awake and busy. But here, in the stillness of nighttime listening, you can almost sense it, the soft hum of existence, the quiet fluctuation beneath everything, the gentle truth that even emptiness is alive. And as all these quantum ideas swirl together, wave functions, uncertainty, entanglement, vacuum energy, a picture emerges that is both strange and comforting, a picture of a universe that is not cold or mechanical, but delicate, subtle, a universe where nothing is ever truly alone, a universe built not from solid bricks, but from relationships, from interactions, from possibilities, leaning gently into reality, a universe where the small shapes the large, the unseen shapes the seen, and the mysterious supports the familiar, where everything, absolutely everything is connected, even when it feels like it isn't. There's a moment when you think deeply enough about quantum physics where the line between out there and in here starts to blur. Not in a mystical or magical way, but in a quiet, matter-of-fact way that feels almost more profound. Because once you understand that everything around you is made from quantum fields, the table, the air, the stars, you realize something else. You are made of them too. Your body, your memories, your thoughts drifting tonight as your eyes grow heavier. All of it emerges from patterns in those same fields. The boundary between you and the universe dissolves a little. You're not an observer looking at the quantum world from the outside. You're a participant, a ripple in the same ocean you're trying to understand. Take the atoms in your body, the carbon, the hydrogen, the oxygen, the nitrogen. Each atom is a tiny, shimmering structure held together by the quantum rules that keep electrons in their gentle probability clouds. But those atoms aren't quiet. They're buzzing. Their electrons are constantly jumping between energy levels, emitting little flashes of light too tiny to see. Your body isn't still at all. It's glowing at a microscopic scale, whispering photons into the darkness. Even in perfect rest, you are radiant in ways your senses can't detect. And when you zoom in even further, the particles inside those atoms aren't objects sitting in space. They're events, ripples, excitations of fields that span the entire cosmos. In that sense, you're not sitting in the universe. You're sitting as the universe, arranged temporarily into the shape of a person. This interconnectedness becomes even more astonishing when you consider how unstable the building blocks of matter really are. The protons in the atoms of your body are made of quarks, bound together by the strong force, a force carried by gluons that exchange energy billions of times per second. It's frantic down there, like the boiling surface of a tiny sun, and yet you feel none of it. All of that chaos resolves into stillness from the outside, the same way a roaring crowd, viewed from far away, looks like a single, quiet shape. The quantum world is noisy, dynamic, full of motion, but it gives us a world that feels peaceful and stable enough to fall asleep in. And then there's the uncertainty woven into every quantum process. The idea that the universe doesn't choose a single path until it absolutely has to. A particle exists in a blur of possibilities until something nudges it into one definite outcome. It isn't random in a disorderly way. It's random with structure, random with rules, like a river that meanders unpredictably but still flows downhill. When you think about your own life, it's not so different. So many paths you could take, so many versions of yourself you could become, and yet somehow one version crystallizes each day as you move forward.
There's something poetic in that parallel. The universe itself is comfortable with uncertainty. Maybe we can learn to be too. Entanglement takes this even further. Imagine two particles that interact for just a brief moment before flying apart. Once entangled, they become parts of the same equation, no matter how far they travel. Measuring one instantly reveals something about the other, even years later, even across the width of a galaxy. It's not communication. It's not magic. It's simply nature refusing to fully separate things that have touched. And when you think about the people in your life, the ones who have shaped you, hurt you, loved you, stayed with you, or left, maybe it isn't so strange to imagine that we too leave imprints on one another that distance can't fully undo. Not physically, not scientifically, but emotionally. The universe hints at connection everywhere you look.
Even the vacuum reminds us of this. The empty space between stars, between atoms, even between the particles inside those atoms. It's not barren. It's full of fluctuations, a constant hum beneath the silence. Virtual particles appear and vanish. Energy rises and falls. Forces stretch across the emptiness like invisible threads. In a way, the vacuum is the most honest thing in the universe. It looks empty, but it's secretly full. It looks still, but it's continuously alive. Maybe people are like that too, holding entire storms under calm surfaces, carrying invisible histories in quiet hearts, vibrating with emotion beneath everyday stillness. And as we follow these ideas deeper, quantum physics starts to feel less like a theory and more like a lens, a way of seeing the universe that reveals hidden softness. Beneath the solid shapes of the world is a shimmering uncertainty. Beneath the certainty of classical laws is a foundation built from probability. Beneath the boundaries we believe in are connections we don't always recognize. The quantum world doesn't just challenge our understanding, it gently expands it. It asks us to loosen our grip on the familiar and accept that reality is richer, stranger, more fluid than we ever imagined. And maybe, as your breathing slows and your thoughts quiet, there's comfort in that. You don't have to understand every equation to feel the beauty of the ideas. You don't have to solve the mysteries to rest in them. There's peace in knowing that the universe is vast and unknowable. And yet, here you are, listening, feeling the soft weight of your body sinking into rest. Part of that same vastness, there's a part of quantum physics that feels almost like a secret, not because it's hidden, but because it's so easy to overlook. We spend so much time talking about particles and probabilities and strange experiments that bend our idea of time, but underneath all of that is something quieter. A simple truth that's easy to forget. Quantum physics is the reason anything exists at all. Without the uncertainty principle, without fluctuations in the vacuum,
Without the peculiar slipperiness of particles that refuse to stay in perfect balance, the universe would have settled into stillness. No stars, no atoms, no light, no warmth. The early universe would never have formed galaxies because the tiny imperfections, the little ripples that allowed matter to clump together, came from quantum fluctuations. In other words, everything you see today, from spiral galaxies swirling across the cosmos to the pattern of freckles on your skin, emerged because the universe was never perfectly smooth. Perfection was broken by randomness, and that randomness created beauty. Imagine the earliest moments after the Big Bang, the universe expanding faster than light, space stretching so rapidly that tiny quantum jitters were frozen into place. Small regions with slightly more energy, slightly more density, tiny bumps and wrinkles that, over billions of years, would become clusters of galaxies, star nurseries, and eventually planets like this one. The entire large-scale structure of the cosmos, the deep cosmic web stretching across light years, is, in a sense, a reflection of the quantum foam that once rippled at a scale smaller than atoms. When you look at a picture of the universe on the grandest scale, you're looking at a magnified map of quantum fluctuations from the dawn of time. There is something breathtaking about that. The smallest things influencing the largest, the quietest whispers shaping the loudest symphonies. It's a reminder that even the tiniest uncertainties in our lives can lead to outcomes we could never predict. And when you sit in the dark, listening to a story about quantum mechanics while the rest of the world grows still, it's easy to forget how connected you are to that ancient origin. But you are. The atoms in your body aren't just recycled from old stars. They're arranged in patterns sculpted by those first quantum imperfections. The distribution of matter in your bones, the chemistry in your cells, the electricity in your nerves, all of it flows from the delicate imbalance in the universe's earliest moments. Your existence is not an accident. It's the natural unfolding of quantum physics across cosmic time. You're not separate from the universe's story. You're one of the latest paragraphs still being written.
When physicists study the cosmic microwave background, the ancient afterglow of the Big Bang, they see little temperature variations, tiny spots just a little warmer or cooler than their neighbors. Those spots are the fingerprints of quantum fluctuations magnified by cosmic inflation. They are the echo of the universe's childhood, imprinted on the sky like a photograph. And when you realize that, when you understand that the light that has been traveling for nearly 14 billion years carries evidence of quantum jitters too small to imagine, it becomes hard not to feel a kind of tenderness toward the universe, as if it too started with tremors and uncertainties, as if creation itself was born from imperfection. And the longer you think about this, the more quantum physics becomes not just a scientific theory, but a way of relating to existence. The way uncertainty can lead to structure. The way randomness can create meaning. the way connections can persist across unimaginable distances, the way emptiness can still hum with potential. The universe isn't cold or chaotic. It's intricate, delicate, balanced between order and disorder in a way that makes life possible. And even if the equations are difficult, the message they whisper is simple. The world is softer than you think, more flexible, more forgiving, more open to change. As you lie there, maybe watching the shadows stretch along the ceiling, or feeling the warmth of your blanket against your skin, you're participating in that same cosmic process. You're a pattern of quantum fields cooled into consciousness, a ripple that learned to wonder about itself, a brief moment of awareness in a universe far older and far stranger than human intuition can grasp. But that awareness, your awareness, is also part of the universe learning to understand itself. When you listen to stories of wave functions and uncertainties, when you picture electrons shimmering in probabilistic clouds, the universe is reflecting on its own nature through you. And maybe that's why these ideas feel so soothing in the quiet hours of the night. They remind you that you're not expected to have everything figured out. Not tonight, not tomorrow, not ever. The universe itself doesn't reveal all its answers. It leaves room for possibility, for change, for the unexpected. Even the laws of physics allow space for uncertainty. So, maybe you can allow that too, inside yourself. There's a quiet comfort in realizing that even the most fundamental parts of reality don't stay perfectly still. Electrons fluctuate, fields ripple, particles appear and vanish like tiny breaths. Nothing in the universe is ever truly frozen. Everything is in motion, gentle, constant motion, even when it looks perfectly still. And there's something soothing about that, especially at night when your thoughts begin to drift in slow circles. You don't have to be perfectly still inside either. You don't have to silence every thought or organize every worry. The universe itself allows its smallest pieces to shimmer, to wander, to exist in uncertainty. Maybe you can give yourself permission to do the same. Quantum physics teaches us that stability doesn't come from stillness, but from balance. A balance between noise and structure, between motion and rest. The atoms in your body don't stop vibrating when you sleep. They keep buzzing softly, like a faint cosmic melody playing beneath the surface of your life. Even your thoughts, the ones drifting quietly right now, are shaped by electrical impulses traveling across quantum-driven chemical pathways. You're made of motion. You're made of fluctuations. And yet, you feel whole. You feel continuous. You feel like one complete thing. That's the miracle of emergence. The way countless tiny events
physics as cold or mechanical, like a set of rigid rules written in alien mathematics. But when you let the ideas settle into you, when you let them unfold at their natural pace, they start to feel surprisingly gentle, not harsh, not chaotic, just different. A different kind of logic, a different kind of beauty, a different kind of truth, a truth that doesn't demand certainty, a truth that allows for softness, a truth that leaves room for wonder. And maybe that's why thinking about quantum physics late at night feels so peaceful. It invites you into a world where not everything has to make sense right away, where you can rest even without answers, where mystery isn't a threat, it's a place to breathe.
Take quantum tunneling, for example. The ability of a particle to slip through a barrier it shouldn't be able to cross. Classically, it's impossible. The barrier is too tall or too thick. But quantum mechanically, the particle isn't a tiny billiard ball. It's a wave of probability. And part of that wave can seep through the barrier, appearing on the other side as if the barrier were more suggestion than law. That's how fusion happens in the sun. That's how certain chemical reactions unfold in your body. That's how tiny processes that power life find their way forward. Even in the smallest spaces, even in the hardest moments, the universe finds paths through walls that appear unbreakable. There's a metaphor hiding there, a quiet one, not a loud promise that anything is possible, but a gentler whisper. Sometimes there are ways through that you can't see yet. Sometimes what looks solid and final becomes permeable when you approach it from a different angle. Sometimes barriers soften in ways you wouldn't expect. In the quantum world, impossibility is not absolute. It's negotiable. And in your world, your personal, human world, maybe some impossibilities are softer than they seem too. And then there's the quantum vacuum, the most paradoxical place in physics. A place that should be empty but isn't. A place with no particles that is still full of energy. The vacuum is not nothingness. It's potential. Infinite, restless potential. Virtual particles flicker in and out. Fields sway gently. Possibilities bloom and collapse in a constant, silent rhythm. When physicists study the vacuum, they see not emptiness, but structure, not silence, but hidden music. And maybe that resonates with something inside you. The idea that even when you feel empty, there's still something quietly alive inside you. Still warmth, still possibility, still a gentle pulse of potential waiting to take shape when you're ready. The more time you spend in the quantum world, the more you realize that it isn't separate from the world you know. It's the foundation beneath everything, beneath the stars, beneath the oceans, beneath the breath you're taking right now. You don't live above the quantum world. You live inside it. You are made of it. And that makes the entire universe feel a little closer, a little more intimate. Not a distant, unreachable vastness, but a place that holds you the way a pattern holds each thread. You are woven into the fabric of existence at the deepest level. And maybe, as your body sinks a little heavier, and your thoughts soften like ripples fading across a pond, that's all you need to know. That beneath the noise of everyday life, beneath the questions and the worries, beneath the surface of everything, there is order, there is structure, there is connection, and even in the smallest trembling parts of reality, there is beauty. One of the most remarkable things about quantum physics is how it gently dissolves the idea of separateness. In the classical world, we imagine objects as isolated. This cup is over here, that lamp is over there, and the distance between them is empty space. But in the quantum world, distance doesn't mean disconnection. Particles can become entangled, fields can overlap, and the vacuum itself can knit everything together in ways we can't see. Even the light in the room around you, soft, indirect, maybe just a faint glow from your phone screen, is made of photons that were created by interactions happening all across the universe. Interactions that ripple through space and through time before finally brushing gently against your eyes. Everything is touching everything all the time in ways too delicate for your senses to detect. You can almost imagine the universe as a tapestry, but not a tapestry woven from threads. Instead, a tapestry woven from relationships. Every particle exists only because the fields around it allow it to exist. Every force is a conversation between excitations in those fields. Even your body is a constellation of interactions happening moment by moment. When you breathe, electrons and oxygen atoms slip into the dance of your molecules. When you think, ions flow across neuron membranes in delicate patterns. Every thought, every memory, every emotion is built from quantum interactions scaled up into something you can feel. And in that sense, you're not a single thing. You're an ongoing event, a process, a story written in ripples of energy. Sometimes, when you think about quantum physics late at night, it feels almost like the universe is whispering its secrets through the cracks of understanding. Not loudly, not clearly, just enough to let you know there's more happening beneath the surface. Something subtle, something alive. You begin to notice how many things in your own experience echo quantum ideas. The way thoughts interfere with one another, like waves overlapping. The way possibilities collapse into choices. The way memories entangle with emotions so tightly that thinking of one instantly brings back the other. The way life is filled with uncertainties that eventually guide you into a single path. Quantum physics doesn't mirror human experience by accident. It mirrors it because human experience is built from quantum rules. And then there's the phenomenon of quantum superposition, the idea that something can exist in multiple states at once until it's observed. It's one of the strangest concepts in physics, and yet it applies beautifully to the way people live. How often do you carry multiple possibilities inside you? The person you are, the person you were, the person you might become, future versions of yourself branching quietly in your imagination, waiting for the right moment to unfold. You hold those possibilities the same way a particle holds its potential states, and like a wave function collapsing, you step into one future at a time, not because the others weren't real, but because life nudges you towards certainty when you're ready. Quantum physics also reveals that measurement isn't passive. It's participatory. The act of observing changes the system. Collapse happens. States define themselves. And when you think about your life, it's not so different. The moment you pay attention to something, really pay attention, it changes. Not because your mind is powerful in a magical way, but because attention shapes experience. A worry shrinks when you look closely at it. A feeling deepens when you allow yourself to feel it. A dream solidifies when you give it space. Attention collapses possibility into reality. And in that sense, every day you're doing your own kind of quantum measurement without ever needing to think about it. Even the uncertainty principle feels tender in a way. The idea that you can know where something is or how fast it's moving, but not both with perfect clarity. It resonates with the rhythm of life. You can know where you are, but not exactly where you're going. Or you can know where you want to go, but not exactly where you are. Certainty in one direction creates uncertainty in another. And maybe that's okay. Maybe the universe is telling you that you don't need to have perfect clarity to keep moving. As you sink deeper into the quiet of this moment, you might start to feel how the ideas soften, how the edges between concepts blur, how the boundaries between scientific and emotional fade into something smoother, something easier. Quantum physics doesn't need to be sharp to be understood. It can be gentle. It can be something you feel more than something you calculate. Something that settles into your breath, into your chest, like a soft warmth spreading through a cool night. And maybe that's the secret beauty of all of this. Quantum physics isn't just about the universe. It's about how you belong to it. Before there were particles, before there were atoms or light or heat, before there was anything you could point to or imagine, there was a moment so small and so dense and so quiet that even calling it a moment feels like a stretch. It wasn't a place, it wasn't a thing, it wasn't even a point in space, because space didn't exist yet. It was simply potential, a compressed possibility waiting to soften, waiting to stretch, waiting to breathe. Then, slowly, impossibly, it did. What we call the Big Bang wasn't an explosion in space. It was the birth of space. A swelling, a loosening, a warm bloom of energy unfolding from a state so concentrated it defies imagination. The universe didn't burst outward into emptiness. There was no emptiness. It created the emptiness as it expanded, like ink swirling into paper that hadn't been there before. And out of that swelling came the first whispers of structure, quantum fluctuations, tiny ripples in the fabric of reality, gentler than breath, softer than dust. These ripples were random, but not chaotic. They were patterns waiting to grow, seeds of galaxies, seeds of stars, seeds of everything. It's strange to think that the largest things in the cosmos, clusters of galaxies stretching across billions of light years, began as tiny irregularities. But that's how the universe works. Not with sharp corners or perfect symmetry, but with gentle variations, slight imbalances, small imperfections that snowball into wonders. If the universe had been perfectly smooth, nothing would have happened. No stars, no planets, no life. Perfect symmetry would have been perfectly silent. So, the next time you feel imperfect, remember, the universe only exists because of tiny unevenness. Creation needs a little disorder to unfold. As the universe expanded, it cooled, and cooling allowed energy to condense into matter, first quarks, then protons, and neutrons, then simple atoms like hydrogen and helium. For a long, long stretch, the universe was a warm fog, glowing and dense, filled with newborn particles drifting in a haze. Light could not travel far. Everything was too crowded, too tangled, too busy. But the expansion continued. The fog thinned, and around 380,000 years after the beginning, something beautiful happened. Atoms formed, stable, quiet, neutral, and suddenly, for the first time, light was free. It streamed across the cosmos in every direction, no longer trapped. That ancient light is still traveling today. It's the cosmic microwave background, the oldest photograph of the universe, still whispering to us from all sides. If you close your eyes right now and just breathe, you are wrapped in that glow. Every room you've ever slept in, every night sky you've ever walked beneath, every moment of your life has been bathed in light, older than the oldest star. It's faint, but it touches everything. Then slowly, gravity took the lead. It tugged matter into clumps. Clouds collapsed into stars. Stars gathered into galaxies. And inside those stars, in their burning hearts, new elements were forged. Carbon, oxygen, iron, everything that would one day become oceans, mountains, forests, and the delicate scaffolding of your own body. It's easy to forget how much time this took. Billions of years, whole generations of stars living, dying, scattering their ashes into space. The universe was patient. It didn't rush. It allowed things to unfold gradually, layer by layer. Sometimes we forget to give ourselves that same patience. You are made of stardust, but you are also made of cosmic timing, of slow processes, gentle accumulations, long arcs of transformation. You were not meant to have everything figured out all at once. Even the universe didn't. And in the emptiness between galaxies, in the darkness that seems so still, quantum fields still hum softly. Space is not empty at all. It teems with potential, with fluctuations, with virtual particles flickering in and out of existence in rhythms too quiet to hear. Even the vacuum is alive in its own way. When you breathe slowly, when your thoughts begin to soften, when your body grows heavy with rest, you're aligning yourself with that quieter rhythm, the one the universe has kept since its first heartbeat. A rhythm older than time, a rhythm that underlies every atom around you. The story of the universe isn't a story of violence or chaos. It's a story of unfolding, of expansion, of transformation shaped by gentle imbalance and quiet probability. It's a story that mirrors your own life more than you might realize. There's a quiet moment in the story of the universe where things begin to shift from simple expansion into something more structured, more textured, more alive. After the first stars ignite, the darkness that once felt endless begins to change. Light travels farther. Gravity gathers clouds into shapes. The universe, once a smooth and glowing haze, starts forming intricate patterns, almost like frost spreading across a window. Filaments of matter thread through the cosmos. Clusters form at their intersections. Space itself starts to resemble a kind of cosmic lace, delicate and enormous. As you lie here listening, maybe you can imagine this transformation happening very slowly, the way dawn creeps across a landscape without ever making a sound. There's no rush, no urgency, just patient unfolding. That's how galaxies began. Small islands of stars drifting together, merging, colliding, stretching, winding themselves into spirals and ellipses. Each galaxy a home for billions of suns. Each sun a furnace shaping elements. Each element eventually part of something larger. The Milky Way, the galaxy you call home, began as one of those early islands, small, humble, nothing like the luminous swirl it would one day become. Over billions of years, It grew by drawing in smaller galaxies, like a slow cosmic dance where partners merge rather than separate. Stars formed in waves, clouds collapsed again and again, creating generations of starlight. And in the quiet corners, dust began to gather into disks, and disks into planets, and planets into places where chemistry could play its long, patient game. You might not think of yourself as connected to those early events, but you are. You're listening to this in a body made from the ashes of those ancient stars, atoms forged by heat older than memory, older than oceans, older than sleep. Everything you are, every heartbeat, every breath, every drifting thought is the result of a long chain of cosmic events that began in those first flickers of starlight. And if you take a slow breath now and let it out gently, you might feel just a hint of that interconnectedness, like a faint vibration running through everything. You're part of something vast, but not in a way that overwhelms. More like being part of a giant, peaceful symphony where every instrument plays softly and every note blends into the next. You're not separate from the universe. You're woven into it. As galaxies formed, something else began to whisper through the cosmos. Gravity waves, not the kind we detect with fancy instruments and huge observatories, but the gentle ripples created by objects moving, orbiting, merging. When two stars orbited each other, when a black hole twisted space, when a cluster shifted even by a fraction, space-time itself rippled. These waves travel even now, passing through you as you lie here, though they're far too faint to feel. But they're real, like cosmic lullabies, humming quietly, endlessly, across billions of light years. It's comforting to imagine the universe not as a cold, empty void, but as something dynamic, elastic, and full of texture. Space isn't rigid. It moves. It breathes in a way, not literally, but metaphorically, stretching and relaxing with the mass and motion of everything inside it. And you, being made of that same fabric, move gently with those waves, even when you're still. Somewhere in those early galaxies, new stars began to form with heavier elements. Carbon, oxygen, nitrogen, iron. These elements came from the hearts of the first massive stars, which lived fast and died dramatically. When those early giants exploded, they seeded space with the ingredients for future worlds. Whole solar systems were built from these scattered remnants. If you could watch that process in slow motion, it would look almost like a dance of dust and gas, spiraling, gathering, flattening, glowing, never still, never hurried. Planets began forming one after another,
countless worlds taking shape around countless stars. Some were rocky, some were gaseous, some were frozen, some burned with molten seas. A few, very few, landed in just the right conditions for something extraordinary to begin happening. Chemistry, which had been dancing quietly in clouds and stars, began experimenting on the surfaces of these young planets. Molecules met, combined, broke apart, reformed. Over unimaginable stretches of time, complexity emerged. And somewhere on one small blue planet, circling an unremarkable star in a spiral galaxy, chemistry became biology. Life didn't arrive with fanfare. It appeared like a whisper, a slow self-assembly of molecules into something that could copy itself, then something that could adapt, then something that could sense. Life grew in quiet increments, generation after generation, until those tiny threads of existence became forests, oceans, animals, minds, and eventually consciousness. The ability of the universe to look back at itself and wonder, how did all this happen?
That's what you are doing now. You are the cosmos examining its own origins. You are stardust with awareness, a ripple in a quantum field that learned to listen, to imagine, to rest. You don't need to solve the entire universe to belong in it. Your presence here is already part of its story. As the universe kept expanding, something unexpected happened. It didn't slow down, it sped up. Galaxies began drifting apart faster than gravity could pull them together. Space itself began stretching more quickly. This acceleration is still one of the great mysteries, something we call dark energy, a name that means we see the effects, but we don't fully understand the cause. And that's okay. Not every mystery needs to be unraveled tonight. Some are meant to be lived with, gently, patiently, like a soft question that stays in the back of your mind without demanding an answer. In the same way, your life also contains mysteries, things you don't understand yet, things that feel unfinished or unsettled. And that's part of your story, too. Not every answer arrives right away. Some answers grow slowly, like stars forming from cloud light. Some arrive when you're not looking. Some arrive only when you're ready to hear them. As galaxies drift farther apart and the universe grows colder and quieter, we find ourselves in a peculiar moment, far from the beginning, nowhere near the end, but exactly in the middle of a universe that is still writing itself. And in this middle moment, you are here, resting, breathing, letting your thoughts soften like dust settling in the gentle pull of gravity. Right now, the universe isn't asking anything of you. It's just keeping you company. If you feel your eyes growing heavy, let them. If your breath is slowing, let it. If the world around you grows quiet, let it. A universe this vast also has room for your rest. There's a quiet kind of magic in the way stars are born, a magic that unfolds slowly in the deep silence of space. It begins in dark molecular clouds, places where starlight barely reaches, where dust gathers in thick, drifting curtains. These clouds look empty from afar, like patches of shadow, but inside them, the density is so gentle, so subtle, that you could travel for years and never notice anything growing heavier around you. Yet, gravity feels it. Gravity notices everything, even the faintest imbalance, and begins its patient work. At first, nothing seems to happen. The cloud stays cold, quiet, drifting through the galaxy like a veil. But over time, thousands of years, millions, sometimes tens of millions, gravity tugs just a little harder in some places than others. Tiny clumps form, whisper small at first, then they grow, attracting more gas, more dust, folding in on themselves like hands closing around a delicate flame. As these clumps gather mass, they heat from within. Compression becomes warmth, warmth becomes pressure, pressure becomes a gentle glow. And one day, though day is too human a word for such timescales, the glow brightens, the center ignites, hydrogen fuses into helium, light spills into space. A new star exhales its first breath of radiation, and the darkness around it shimmers with newborn starlight. It's astonishing to think that this is how your own sun began, slowly, quietly, alone in a dark cloud that no longer exists. And even more astonishing to think that within that cloud, surrounded by millions of other stars being born across the galaxy, the atoms that would one day become your body were already drifting, already part of the story. Long before Earth formed, long before oceans or forests or human thought, the ingredients for you were swirling through space, waiting. Once stars form, planets often follow. Not always. Some stars drift through life without companionship, but in many cases, the leftover dust and gas begins to flatten into a disk around the young star. It spins, slowly at first, then faster as particles collide and merge. Pebbles form, boulders form, worlds form. Some grow large enough to hold thick atmospheres. Others remain small, barren, cracked by impacts and starlight. Our solar system was messy at the beginning. It wasn't the neat, predictable arrangement you see in textbooks. It was chaos sculpting itself into order. Millions of asteroids racing through the early disk, planets shifting, colliding, migrating. Even Jupiter moved inward and outward in those first turbulent millions of years, dragging material with it, sculpting the architecture of the young sun's family.
And somewhere in that shifting disk, Earth took shape, a molten sphere glowing red-hot under constant bombardment.
But eventually things cooled. Rain fell for the first time. Not just drops, but endless oceans pouring from the sky. Lightning split the early atmosphere. Volcanoes breathed out gases. And in this electrically charged ocean world, molecules began to assemble in ways they never had before. They formed tiny structures that could replicate, mutate, survive. And just like that, though just hardly does it justice, life flickered into existence. Across billions of years, that life deepened, expanded, evolved. Cells learned to cooperate. Organisms began to sense light, then movement, then fear, then curiosity. The world grew forests and fish and insects and creatures that left footprints in soft mud. And eventually, after all that time, the universe grew something else. Awareness. Not just survival, not just instinct, but the ability to wonder. The ability to ask the kinds of questions that keep you awake at night. The ability to lie in the quiet and imagine the beginning of everything. The ability to listen to this and feel a soft sense of belonging. One of the most beautiful truths in physics is that life, consciousness, awareness, none of it is separate from the laws of the universe. Your thoughts are quantum patterns in your brain. Your memories are chemical traces woven into electromagnetic signals. Your dreams are ripples in your neural fields. The universe didn't just create stars and planets. It created a way for those stars and planets to look back at themselves through you. Black holes play a role in this story too. Enormous, dark, silent engines in the centers of galaxies, sculpting orbits, shaping structure, bending space-time into elegant curves. They sound terrifying, but the truth is more subtle. Black holes aren't hungry monsters. They're simply regions where gravity has pressed matter into a density so extreme that space folds inward. They don't chase anything, don't devour anything unless something drifts too close. They are cosmic, still points, incredibly dense, incredibly calm. Our own galaxy harbors one. Sagittarius, a star, a supermassive black hole 4 million times the mass of the sun. And yet, if you were drifting near it, far enough from the event horizon, you wouldn't feel fear. You'd feel awe. The stars around it move like dancers in a perfectly choreographed spiral. The space near it bends like liquid glass. It's quiet, soft, like a deep inhale, held at the center of a cosmic breath. Even the way black holes form is slow and gentle from their point of view. A massive star exhausts its fuel. It collapses inward. Light can no longer escape. And what remains is a point of infinite density wrapped in curved space. But around it, swirling disks of gas, jets of particles, magnetic fields so intense they arc through space like ribbons. Black holes aren't endings, they're transformations, gatekeepers between what we understand and what we still dream about. And perhaps the most comforting thing of all is this: even as the universe expands, even as galaxies drift farther, even as stars live and die, the laws governing everything remain beautifully consistent. The quantum fields that shaped the first particles are the same ones shaping your body right now. The nuclear forces that forged elements in ancient stars are the same forces burning in the sun as you listen. The electromagnetic waves that light our world are the same waves pulsing gently from distant galaxies. The universe is not chaotic. It's not random noise. It's a gentle, continuous unfolding. It has room for galaxies and atoms and minds and dreams, all woven together by rules that feel almost musical in their harmony. If your eyes are growing heavy, let them sink. If your breath is slowing, let it flow. You are drifting in a universe that has been calming itself for billions of years. Dark matter is one of those quiet mysteries that never raises its voice, never flashes brightly, never pulls attention the way stars do, yet its presence shapes almost everything. You can imagine it like a soft gravitational wind blowing through the universe, invisible, silent, but essential. Without it, galaxies wouldn't hold together. Stars would drift apart like petals in a breeze. The Milky Way itself would unravel. And perhaps you wouldn't be here at all, lying in the dark, letting your mind float gently through these cosmic thoughts. We can't see dark matter directly. It doesn't emit light or absorb it. It doesn't glow, doesn't shimmer, doesn't leave footprints in the electromagnetic world. But we feel its gravity. We see how it bends the paths of stars, how it tugs on galaxies, how it sculpts the large-scale structure of the universe. When astronomers map where galaxies gather in clusters, they find patterns too intricate, too stable, too vast to be explained by visible matter alone. Something unseen is holding the cosmic web together. Something massive, something everywhere. When you think of matter, you probably picture things you can touch. Your pillow, your phone, your own hands. But ordinary matter, the kind made of atoms, is only 5% of the universe. The rest is invisible scaffolding, a framework of gravity woven through the cosmos by something we still don't fully understand. And yet, even without understanding its identity, we know dark matter is there, just as you can feel the presence of someone standing quietly behind you, even if they don't speak. Maybe there's comfort in that idea, that the universe is supported by things we cannot see. That invisibility doesn't mean insignificance. That sometimes
ones that don't make a sound, yet hold everything together when we feel like falling apart. Scientists have proposed many possibilities for what dark matter could be. Some think it's made of particles unlike any we've ever encountered. WIMPs, axions, sterile neutrinos, or something even stranger. Others imagine new kinds of symmetry, new fields, new dimensions subtly influencing our own. But whatever dark matter is, it behaves with remarkable grace. It doesn't collide with ordinary matter. It doesn't tangle or cling. It simply floats, passes through, supports, shapes, a silent partner in the cosmic dance. And if dark matter is the hidden structure, then dark energy is the hidden motion, a mysterious pressure pushing the universe to expand faster and faster. It's strange to think about the cosmos accelerating, as though space itself were stretching with increasing enthusiasm, like a breath that deepens without you noticing. Dark energy makes up nearly 70% of the universe, yet we barely understand it. It doesn't behave like matter. It doesn't clump. It doesn't weigh down. Instead, it acts like a gentle repulsion woven into the very fabric of space. Imagine holding a soft cloth between your hands and slowly pulling it apart. That slow stretching, that widening, that's a little like what dark energy does, except instead of fabric, it's stretching reality itself. Every minute, the space between galaxies grows a little wider. Every hour, the expansion eases open just a bit more. And here you are, on a tiny planet, orbiting a small star, in one of billions of galaxies carried effortlessly along by this gentle cosmic drift.
Dark energy might sound eerie or unsettling, but in truth it's calm. A quiet, uniform presence that has always been here, always guiding the tempo of cosmic expansion. It doesn't surge. It doesn't pulse. It's steady, reliable, patient. And maybe there's something comforting about accepting that some mysteries aren't threatening. They're simply beyond our current horizon, waiting to be understood when the time is right. It's strange how the universe mirrors the human experience in this way. There are forces within you that are visible. Your emotions, your memories, your choices. And there are forces you barely notice, shaping you quietly from within. Subconscious habits, quiet resilience, hidden strengths. Sometimes the things that guide you most deeply are the ones you don't fully see. Just like dark matter, just like dark energy. Galaxies continue drifting through the cosmic sea, shaped by these invisible forces. Stars orbit in calm spirals. Clouds collapse into new suns. Entire clusters move through space like slow, glowing islands, carried by currents we can only trace through mathematical maps. And beyond every bright object, beyond every photon ever emitted, lies more darkness, but not an empty darkness, a full darkness, a structured, meaningful, necessary darkness. The universe isn't a battle between light and dark. It's a collaboration. Light gives shape. Dark gives structure. Light reveals. Dark supports. One is not better than the other. They are two halves of a single cosmic breath. And you, drifting into rest, are made of both. Atoms from ancient stars, and spaces between those atoms that are mostly emptiness. You are matter and silence, energy and stillness, complexity and calm. As expansion accelerates, galaxies begin slipping beyond one another's reach. Light that once connected them becomes too stretched, too faint, too slow. Over trillions of years, the sky will grow darker as galaxies retreat beyond the horizon of visibility. But that's not something to mourn. It's part of the quiet evolution of the cosmos, the natural life cycle of space-time. And right now, in this brief, luminous window of cosmic time, you exist. You can look up and see the Milky Way. You can feel the warmth of a star across 150 million kilometers of emptiness. You can think and wonder and dream. One day, the universe will grow so wide that galaxies will drift alone in their own patches of space. But you are alive now, in a moment when the sky is rich and full and generous. And even when you sleep, even when your thoughts dissolve into soft, drifting images, the universe continues gently expanding around you like a long exhale. If you could peel back the layers of the universe, all the galaxies, all the stars, all the atoms, you wouldn't find machinery or gears or anything solid at the deepest level. You would find fields, vast, continuous, almost featureless fields, stretching through all of space like smooth, invisible oceans. Every particle you've ever heard of, electrons, quarks, photons, is not a tiny marble, but a ripple in one of these fields, a vibration, a disturbance, a note in a cosmic harmony so deep and so quiet that most of the time we don't even notice it. But everything, absolutely everything, rises from those vibrations. The electron field is everywhere, even in the room you're in right now, even in the empty spaces between your thoughts. The quark field, the neutrino field, the photon field, they're woven into each other, overlapping like layers of silk, each one humming with potential. In quantum field theory, there is no such thing as true emptiness. Even the vacuum is alive with subtle motion. Pairs of particles flicker into existence for a breath,
then vanish again, borrowing energy from the uncertainty of the quantum world. It's like the universe is whispering to itself beneath the threshold of reality. When you lie still, eyes closed, breath soft, there's a strange comfort in imagining that every atom in your body is just a gentle ripple in these fields, that the boundaries you think of as you are not sharp edges, but smooth gradients fading into the deeper fabric of reality. You're not a separate object drifting through the universe. You're a pattern within it, a temporary arrangement of waves, like a melody sustained for a brief moment before dissolving back into silence.
Think about an electron for a moment. It's one of the most familiar particles in nature, but the more we've learned about it, the stranger it becomes. In quantum mechanics, an electron doesn't have a single location or a single state. It exists in a cloud of possibilities until measured. It's not a tiny dot orbiting the nucleus, like a planet around a star. That old picture was only ever a metaphor. Instead, it's a probability wave smeared around the atom, a soft presence, a suggestion, and when it shifts from one energy level to another, it doesn't slide or glide. It leaps, instantly, discreetly, like turning a page in a book without touching the in-between. This discreteness is at the heart of quantum mechanics. Light itself is quantized. Photons come in packets, not in continuous streams. Energy levels come in steps. Even the vacuum has quantized fluctuations. The universe, for all its smooth expanses and lazy spirals of galaxies, is made of tiny, indivisible quanta. Little pieces of possibility stitched together into the calm, continuous world you see. Sometimes, when you're drifting towards sleep, the edges of your thoughts become fuzzy. Ideas mix together. Time loosens its grip. Past and present blend. It's not so different from the quantum world, where states overlap until something, an observation, an interaction, a gentle nudge, gives them definition. In that hazy transitional space between wakefulness and dreaming, your mind acts a little like a quantum system, exploring many paths at once, merging ideas, dissolving boundaries. Maybe that's why drifting into sleep feels a little magical, a little strange. You're entering a softer mode of being, one where clarity yields to possibility. The fields that form reality don't exist in isolation. They interact, they couple, they exchange energy in ways that are subtle but profound. The electromagnetic field interacts with the electron field, giving rise to the beauty of chemistry, the entire world of molecules, bonds, colors, tastes, life. The strong field binds quarks into protons and neutrons, holding the nuclei of atoms together with a force so powerful it could tear stars apart or ignite the heart of a nuclear furnace. The
concerns the slow decay of particles, the transmutations that let stars evolve and elements form. All of these interactions, all of these forces, all of these exchanges are described with breathtaking precision in the mathematics of quantum field theory. It's not a simple theory. It's not intuitive, but it works. It works so well that its predictions match experiments to a degree of accuracy so absurd that it feels almost supernatural, as if nature itself were made of equations that hum in perfect tune. And yet, for all this precision, quantum field theory also carries a kind of softness, a humility. It doesn't say, "This is exactly what the universe is." It says, "This is the best map we've drawn so far." It recognizes that beneath its equations there may be deeper patterns, deeper symmetries, deeper truths. The fields might not be the final layer. They might be the middle, or the beginning, or just a bridge between what we know and what we have yet to imagine. When you close your eyes and picture the vacuum as a serene, empty blackness, try instead to imagine something more alive, a shimmering sea of possibility with virtual particles rising and falling like tiny waves. Imagine that every object around you, every atom of your skin, every thought in your mind is a structured disturbance in this sea. Not separate, not isolated, but connected through the deeper substrate of reality. You are not floating in the universe. You are woven into it. The Higgs field adds another layer of mystery and beauty. It permeates space as a subtle drag, a cosmic molasses through which some particles move with ease and others slow down, acquiring mass. Without the Higgs field, particles wouldn't clump into atoms. Atoms wouldn't form molecules. Molecules wouldn't form cells. And you wouldn't be here. The Higgs field is like the softness that lets things gather, settle, and hold their shape. It's gravity's quiet partner, the grounding force behind matter. If you imagine yourself as a ripple in a web of fields, then mass is the way you press against this hidden medium. Your body's weight, the way it sinks into a mattress or settles into a blanket, is a direct consequence of interactions with the Higgs field. Even your sense of stillness, the heaviness of your limbs when you're drifting towards sleep, is part of that interaction. You are not separate from the cosmic fields, you are their expression there.
And somewhere in the deep future, far beyond the lifespan of stars or galaxies, these fields may shift again. The universe may reorganize itself. Space may cool into something even stranger. The fields may fall into a new configuration, and whatever emerges from that change will be as different from us as we are from the earliest particles. But you don't need to worry about that. You're living in a moment filled with warmth and light and breath, a moment where consciousness exists in wonders and dreams. You're here, now, wrapped in the quiet of your own thoughts, carried gently by fields that have existed since the beginning of time. The same patterns that shaped the early universe are shaping you in this very moment. There's a softness to that truth, a kind of cosmic lullaby humming beneath everything. If you imagine the universe as a vast and silent ocean, then space-time is the water, the deep fluid medium through which everything floats, not empty, not rigid, but soft, flexible, gently bending in response to every object, every motion, every whisper of energy. We often think of space as a simple backdrop, a stage on which the drama of matter unfolds. But that's not quite true. Space isn't passive. Time isn't separate. Together they form a fabric, a single entity, stretching and curving and swaying like an immense cosmic sheet. And every particle, every star, every breath you take leaves a tiny imprint on that sheet, a soft indentation, a ripple, a subtle tilt in the smoothness of reality. Einstein showed us that gravity isn't something objects exert by pulling on each other like magnets. It's the shape of space-time itself. Mass bends the fabric. Objects simply follow the curves. When you drop a ball, it's not being tugged down. It's following the natural slope in the space-time landscape beneath your feet. Earth bends space-time. The ball just moves along the curve. And when you stand still, you feel the ground pushing up against you, resisting your natural urge to follow that same curve downward. Even the sensation of weight, that quiet heaviness in your limbs, is your body negotiating with the geometry of space-time. If you were floating far away from everything, in a perfect abyss of quiet and darkness, you would feel weightless, not because gravity vanished, but because nothing is resisting your path through the curved fabric around you. Weight isn't a property of you. It's a conversation between you and the universe, a soft negotiation between your mass and the shape of the space you inhabit. Even that small insight makes everything feel strangely intimate, as if the universe is cradling you, shaping itself around your presence, acknowledging that you exist. The curvature of space-time grows stronger near dense objects. Around Earth it creates a gentle well. Around the sun, a deeper one. Around a neutron star, a pit so steep that light itself struggles to escape its pull. And around a black hole, the curvature becomes so extreme that the very concept of down or direction loses meaning. A place where the fabric of space-time folds inward, tightening like a knot in the universe's vast tapestry. Black holes are not holes in space. They are regions where space-time has collapsed into itself, like a whirlpool
cosmic Z. But even though they are often described as destructive, black holes are not monsters. They're simply the natural outcome of mass and pressure taken to their limits. Silent endpoints of stars that once burned brightly. Cosmic punctuation marks placed at the end of long stellar stories. And even they obey the laws of quantum physics. In the deepest part of their darkness, the horizon that surrounds them is alive with quantum fluctuations. Virtual particles appear, vanish, and sometimes one escapes. Hawking radiation, a slow whisper of energy leaking out over trillions of years. Even the darkest places in the universe glow with the softest quantum light. But before drifting too deep into black holes, look again at space-time from a calmer place. Imagine the fabric stretching under your feet. It's not perfectly smooth. Quantum mechanics says that on the smallest scales, space-time itself shivers. Tiny fluctuations, tiny distortions, a restless uncertainty woven into the very geometry of the cosmos. You'll never feel it in your daily life. The ripples are far too small. But they're there. They are part of the quiet hum beneath reality, like the faintest vibration in the floorboards beneath a sleeping house.
Every object you see, every breath you draw, follows the geodesics, the natural paths carved through this curved fabric. And time itself flows differently depending on position in that geometry. Clocks placed near a massive object tick more slowly, not because the machinery struggles, but because time is stretched. Your own body ages microscopically slower at your feet than at your head. Time is not universal. It's local, personal, shaped by where you stand in the cosmic landscape. When astronauts orbit Earth, they age just a little slower than we do. Not enough to matter in ordinary life, just fractions of a second, but enough to remind us that time is fluid, that the story of your life stretches differently than the story of mine, or the story of a star drifting through the distant outskirts of the galaxy. Time is not the same everywhere. It's shaped by gravity, motion, and the subtle geometry beneath your feet. There's a kind of softness in that idea, a gentleness. Time isn't a rigid rule. It's more like a stream, flowing faster in open, empty spaces and slowing near the heavy presence of matter. And just like a stream, time carries you forward whether you're ready or not. But it doesn't carry everyone at the same speed. It depends on the path you take through space-time. The universe doesn't impose a single rhythm on all things. It allows every object to experience its own tempo, its own quiet pace. Think about the light from distant stars. It bends as it moves past massive objects, curving along the shape of space-time like a leaf drifting along the current of a river. This bending of light, gravitational lensing, lets us see galaxies we would otherwise never glimpse. In a way, the universe uses gravity to magnify itself, revealing hidden corners of the cosmos by warping the pathway of light. Space-time becomes a lens, a guide, a storyteller. And when massive objects move, like two black holes spiraling toward each other, they send ripples through the fabric of space-time itself. Gravitational waves, soft tremors that travel across the universe, carrying with them the memory of cosmic events long past. They stretch and squeeze space as they pass, though the effect is so faint that it takes instruments unimaginably sensitive to detect them. And yet, we have. We've heard the quiet ringing of space-time as black holes collide, merging into one. A faint echo from billions of years ago, reaching us as a hum in the darkness. It's as if the universe has a pulse, a rhythm, a voice. And when you lie quietly in your bed, breathing slowly, you're part of that same fabric. Every heartbeat, every soft inhale, every drifting thought is happening on a sheet of space-time that curves gently beneath you. You are not floating above the universe. You are embedded in it, cradled by it, held in place by its invisible shape. The space around you is not empty. It's responsive. It bends for you. It stretches for you. It carries you forward in time. You are a small, warm ripple in the geometry of the cosmos. When you drift into the quantum layers beneath space-time, the world becomes softer, blurrier, and infinitely stranger. Down here, distance doesn't behave the way you expect. Boundaries lose their meaning. Objects appear, vanish, and reappear as if reality were breathing in and out. A particle can be on one side of a barrier and suddenly appear on the other without ever crossing the space in between. This is quantum tunneling, the quiet, impossible magic that lets stars shine and atoms exist. It's not that the particle forces its way through. It's that probability itself leaks across barriers like mist slipping through the cracks of a window frame. And in that soft leak, new possibilities emerge. Fusion happens at the heart of the sun because of this. If tunneling didn't exist, the sun would be dark, cold, and silent. And so, with the universe, even your heartbeat, your breath, your body's chemistry depends on this whisper of quantum indeterminacy. The more you explore these depths, the more everything begins to feel interconnected, not metaphorically, but physically. Particles become entangled, linked in a way that defies distance.
changes, the other changes instantly, even if they're separated by galaxies. It's not communication. It's not a signal. It's simply connection, a shared state, a relationship embedded in the fabric of the quantum world. Einstein didn't like this. He called it spooky action at a distance. But experiments have shown again and again that it's real. The universe doesn't care whether we think something is intuitive or not. It behaves how it behaves, and entanglement is part of its nature, a silent thread stitching distant parts of reality together.
Imagine two particles born from the same event, twin ripples emerging from a single vibration. As they drift apart, they carry with them a shared memory of where they came from. Not the kind of memory you and I have, but a mathematical one, a correlation in their states. When one is measured, the uncertainty collapses, and the other collapses too, perfectly matched. It's like two coins flipped miles apart that always land with the same face, not because one influences the other, but because they were never separate to begin with. Their link is not through space, but through the deeper structure beneath space. It's a quiet kind of poetry. The universe remembers itself. Quantum superposition adds another layer of dreamlike strangeness. A particle doesn't choose a state until something forces its hand. It can exist in multiple states at once, spinning up and spinning down, here and there, moving fast and slow, like a chord played softly on a piano. The particle is the chord. The measurement is the moment fingers lift from the keys, allowing only one note to ring out. Before that, the music is a blend of possibilities suspended in uncertainty. Superposition is delicate, like silk, like breath. The moment the environment interacts with the particle, the superposition collapses. Decoherence rushes in, turning quantum magic into classical certainty. That's why we don't see macroscopic objects in superposition. Not because the universe forbids it, but because the environment is always watching. Air molecules, photons, vibrations, temperature. Every tiny interaction nudges the system into choosing one state. A cat isn't both alive and dead, not because it couldn't be in principle, but because it's constantly entangled with the environment. It has far too many degrees of freedom to remain isolated. The quantum states blur into classical outcomes almost instantly. Down here in the quantum world, isolation is precious, fragile, difficult. But when achieved, it opens doors into realms that feel almost supernatural. Quantum computers, for example, rely on qubits that remain in superposition long enough to perform calculations impossible for any classical machine. It's like having 1,000 versions of a computer working simultaneously, each exploring a different pathway, then collapsing together into a single coherent answer. The difficulty is keeping those qubits quiet, away from heat, noise, interactions, anything that would force them to choose too soon. But when it works, it's breathtaking, not just technologically, but philosophically. It shows that the universe is capable of far more subtle, intricate behavior than we experience in everyday life. And it makes you wonder, how much of reality is hidden from us simply because we are too large, too warm, too entangled to see it? Quantum tunneling, entanglement, superposition. Each one reshapes the way we think about reality. They blur the lines between here and there, now and later, possible and impossible. They reveal a world built not from solid pieces, but from patterns of probability, woven from fields, blurred by uncertainty, held together by relationships deeper than distance. Even vacuum, the emptiest emptiness, isn't truly empty. It seethes with activity. Virtual particles wink in and out of existence, borrowing energy from the uncertainty principle. It's like the faintest rustle beneath silence, a constant, restless hum. This vacuum energy is everywhere, feeding the expansion of the universe, pushing galaxies apart with quiet persistence. You are floating in it right now, bathed in a sea of invisible fluctuations. Even when you're asleep, even when you're motionless, the vacuum beneath you trembles with potential. And if you could somehow shrink yourself down to the scale of the Planck length, so small that atoms look like entire galaxies compared to your size, space-time itself would appear turbulent, frothy, chaotic. Quantum foam, tiny bubbles of curvature forming and dissolving, miniature wormholes opening and closing, fluctuations twisting the fabric of reality in ways we can barely imagine. Time would jitter, space would tremble, direction would lose meaning, everything would exist in a restless dance of tiny geometries, shifting faster than any measuring device could track. Above all this chaos rises the calm world you know, the world of softness and warmth and breath, a world where time flows gently, where objects hold their shape, where gravity anchors you. But below it, always humming, is the quantum world, not violent or frightening, but subtle, delicate, intricate, a hidden layer of beauty, a deeper rhythm. And maybe this is why sleep feels so strange, because drifting off loosens the boundaries of the self just a bit, allowing your mind to float in a space where logic softens, possibilities blend, and the edges of time blur. Not quantum in a literal sense, but quantum in spirit, dreamy, uncertain, fluid. When you move toward the edge of a black hole, the universe begins to behave in ways that almost feel like illusions. But they aren't illusions at all. They're the true geometry of space-time revealing itself.
Imagine drifting slowly toward a region where gravity becomes so intense that even light, the swiftest traveler in the cosmos, cannot escape. Not because something is pulling it down like a trap, but because space-time itself has curved so steeply that all paths lead inward like a waterfall in the fabric of reality. This boundary, the event horizon, isn't a physical surface. It's a point of no return, a place where the forward direction in time points downward into the black hole. If you cross it, falling inward isn't just inevitable. It's the only direction time will allow. From the outside, though, something even stranger happens. As you drift closer and closer to the event horizon, anyone watching you from afar would see your motion slowing. Your signals would stretch out, your light would redden, your time would appear to freeze. To an observer, you'd never quite cross the horizon. You'd hover there, suspended, dissolving into deeper shades of red until you faded from view entirely. Not because you stopped, but because time itself behaves differently for you than for the observer. Your own journey continues smoothly inward, but from afar, it looks like you're frozen at the threshold. Two timelines, two realities, both true in their own frames. There's something profoundly gentle about that idea, that the universe doesn't impose a single story on its inhabitants. Each observer experiences their own flow of time, their own version of events. Nothing is universal except the laws that guide the curves of space-time. Even reality itself bends around perspective. It makes the universe feel more like a shared dream than a rigid machine. Each viewpoint slightly unique, yet stitched together by the same underlying symmetries. Inside a black hole, the journey becomes stranger still. You won't hit a wall or a barrier. You'll simply drift past the horizon without noticing anything unusual. The boundary isn't marked. It's a change in the mathematics, not in the scenery. What matters is that all paths lead inward, space collapsing into itself, gravity tightening around the core. Eventually, the curvature becomes infinite, or so the classical equations say. A singularity, a point where density becomes unbounded and the laws of physics break down. But many physicists believe the singularity is not a real place, only a sign that our current theories are incomplete. Perhaps quantum gravity, the long-sought marriage of quantum mechanics and general relativity, would reveal a different picture. Maybe space-time resists the collapse. Maybe it becomes discrete. Maybe the information encoded in the fields never truly dies. That brings us to one of the most haunting questions in modern physics. Does information disappear in a black hole? When something falls in, a particle, a planet, a star, a person, what happens to the information that describes its state? The shape, the orientation, the quantum details. Hawking once suggested that information is lost forever wiped away by the singularity. But this idea troubled physicists deeply, because information isn't just a data, it's a fundamental part of reality. The quantum world insists information cannot simply vanish. Every interaction, every change, every ripple in the fields must leave an imprint somewhere.
And so the paradox emerged, a cosmic tension between the smooth geometry of Einstein's equations and the strict bookkeeping of quantum mechanics. If information could truly be destroyed, the universe would break its own mathematical rules. But if information survives, where does it go? The answer may lie on the surface of the event horizon itself. Hawking radiation suggests that black holes slowly evaporate, releasing particles that carry away energy. But what if they carry more than energy? What if they carry the information too, scrambled into near unrecognizable patterns, but preserved nonetheless? Increasingly, physicists believe the event horizon acts like a cosmic archive, a shimmering surface encoding everything that falls inside. Not stored in a file, not accessible in a classical sense, but woven into the quantum fluctuations that surround the boundary. The black hole doesn't erase information, it transforms it. It hides it behind layers of quantum noise, then slowly releases it back into the universe over unimaginable spans of time. This perspective leads to something even more startling: the holographic principle, the idea that everything inside a region of space, everything happening in 3 dimensions, could be described by information living on its 2-dimensional boundary. It's like the universe has a memory etched on its surface, projecting a softer, deeper reality inward. If this principle applies not just to black holes, but to the universe as a whole, then reality might be holographic, not an illusion, but a rearrangement, where the deepest truths live on the edges of things, not the interiors. It's a quiet, almost dreamlike notion that the world around you, the room you're lying in, the breath you're taking, the thoughts drifting through your mind, might in some sense be encoded on a distant cosmic surface, not to diminish your existence, but to reveal that reality has more layers than we can easily see, depths behind depths, textures behind textures, a universe woven from information and geometry, each reflecting the other like ripples on the surface of a lake. And black holes, once feared as cosmic destroyers, become teachers. They show us the boundaries of our knowledge. They reveal where theories break, where new ideas must emerge. They remind us that mystery is not failure. It's a sign that there is more to learn, more to imagine, more to explore. Even in their darkness, they illuminate. If you drift back from the horizon and return to the quiet regions of ordinary space-time, everything suddenly seems gentler, more familiar.
the room around you, the air, the stillness. Yet nothing has changed. Space-time still curves softly under you. Quantum fields still hum beneath the silence. The vacuum still seethes. The atoms in your body still dance between certainty and possibility. You are wrapped in the same cosmic fabric that gives rise to black holes, galaxies, and the entire sky. But now you see it more clearly, not as a distant idea, but as something intimate, something that holds you, shapes you, carries you. If we drift backward, not in space, but in time, far past the stars and galaxies, far past the formation of atoms or even light itself, we approach a moment when the universe was young, small, dense, and hot beyond comprehension. A moment when everything you see around you, every tree, every planet, every star, existed only as energy packed into a space smaller than a grain of sand. This is the earliest chapter of the cosmic story, written not in ink, but in temperature and pressure and quantum fields, roaring with unimaginable intensity. The very beginning, the first fraction of a second, is where our understanding becomes soft and uncertain, like a dream you can't fully recall. We call it the Big Bang, but that name can be misleading. It wasn't an explosion into empty space. It was the rapid expanding birth of space itself, a stretching, a swelling, a sudden release of potential. Time didn't exist before it. Space didn't exist before it. The Big Bang wasn't an event inside the universe. It was the universe beginning to happen.
Right after that initial moment, something extraordinary occurred. Cosmic inflation. A phase of expansion so rapid and so immense that it outpaces every instinct we have about speed, growth, and distance. In an instant, a region smaller than an atom stretched to become larger than a galaxy. Smoothness spread out. Irregularities flattened. Quantum fluctuations were magnified into seeds of future stars and galaxies. Inflation didn't just shape the universe, it sculpted its very possibility. Imagine holding a simple, quiet breath, and with that breath, the entire cosmic horizon expands faster than light itself. This doesn't break any rules, because nothing inside space travels faster than light. It's the fabric of space that's stretching. During inflation, the universe didn't just grow. It unfurled like a flag in a sudden wind. It smoothed out like a sheet being pulled tight. Even now, the echo of that expansion shapes the large-scale structure of everything around you. After inflation calmed, the universe settled into a slower rhythm of expansion, still growing but no longer with the wild abandon of its earliest flicker. The intense heat began to cool. Energy condensed into particles, quarks and electrons, photons and neutrinos. The quark-gluon plasma thickened. Like a cosmic soup, swirled with ingredients too small to see, but essential for everything that would follow. For a brief, glowing moment, the universe was a storm of fields interacting in every possible way, creating matter and antimatter in equal measure. Yet something subtle tilted the balance. For reasons we still don't fully understand, matter gained a slight advantage over antimatter. Just one extra particle for every billion particle-antiparticle pairs. It doesn't sound like much, but it was enough. When matter and antimatter annihilated each other in bright, violent flashes, that tiny excess remained. Those leftovers became everything we know: galaxies, stars, planets, oceans, your body, your breath. You exist because of a small cosmic asymmetry, a gentle imbalance written into the earliest whisper of time. As the universe cooled further, quarks fused into protons and neutrons. Photons filled the cosmos, scattering endlessly, trapped in a fog so thick that light couldn't travel freely. It was like being inside a glowing cloud. There were no stars yet, no galaxies, just a uniform sea of hot plasma and radiation. For almost 380,000 years, the universe remained in this hazy childhood, bright, full of energy, but opaque. And then something miraculous happened. As temperatures dropped, electrons slowed down enough to be captured by protons, forming the first atoms, mostly hydrogen, some helium, a sprinkle of lithium. Suddenly, the fog lifted, light was released. For the first time, photons could travel freely across space. This ancient light still moves through the universe today as the cosmic microwave background, a faint afterglow that fills the sky in every direction. It's astonishing to think that this light has been traveling for nearly 14 billion years, untouched, unbroken, carrying with it the memory of the universe's infancy. When we detect it, we're not just looking at radiation, we're looking at time itself, stretched and cooled, a whisper from the beginning of everything. Once atoms formed, gravity began its slow, patient work. Tiny irregularities left behind by inflation, just little quantum wrinkles magnified to cosmic size, became the seeds of structure. Regions with slightly more matter pulled in their surroundings. Clouds formed. Clumps grew. Over millions of years, these clumps collapsed under their own weight to become the first stars. The first stars were nothing like our sun. They were enormous, hundreds of times more massive, burning ferociously hot, living short lives, dying dramatically in explosions that forged heavier elements: carbon, oxygen, iron, the ingredients of chemistry, the ingredients of breath and blood. These first stars lit the universe for the first time, turning cosmic darkness into a quilt of brilliant fire. And when they exploded, they seeded space with new materials, dust clouds rich with the building blocks of planets. Over billions of years, gravity sculpted more stars, more systems, more galaxies. The Milky Way took shape. Spirals unfurled, clusters gathered. On a small branch of one spiral arm, a star lit up with a calm, steady glow. Around it formed planets, including a small rocky one bathed in gentle warmth. On that world, chemistry played its slow, intricate game. Molecules met, broke apart, reassembled. Rain fell. Oceans formed. Lightning struck. Something stirred in the water. A simple molecule with the ability to replicate. Life. Fragile at first. Simple, but persistent. Over time, complexity rose. Cells learned to cooperate. Organisms learned to adapt. Consciousness bloomed. And eventually, a being emerged who could look up at the night sky and wonder how it all began. You are that being, a descendant of stars, a ripple in the quantum fields that shape the dawn of time. Your thoughts are made from the same particles forged in ancient stellar furnaces. Your consciousness is the universe awakening to itself, learning to whisper its own story. The early universe wasn't something separate from you. It's inside you, written into your atoms, whispered through your cells. When you close your eyes and breathe gently, you are participating in a history that began before time had a name. If you let your mind wander now, not outward into the galaxies, but inward, into yourself, you'll find that the bridge between the universe and consciousness is thinner than it seems. You are, after all, a structure made entirely from particles arranged into patterns, held together by forces that emerged in the earliest moments of the cosmos. Your atoms are ancient. Your molecules are borrowed. The warmth in your chest is the same heat that once lit the first stars. And yet, out of all that quiet physics, something unexpected happened, something subtle, something soft, awareness, the ability to wonder, to question, to imagine what lies beyond the horizon. This is one of the great mysteries of existence, not just where the universe came from, but how the universe learned to look back at itself through your eyes. How something as delicate as a thought could arise from quantum fields arranged into neurons, into networks, into memories that stretch across a lifetime. It didn't happen all at once. The journey from stardust to sentience was long and filled with changes so gradual they barely left footprints in the sand of time. For billions of years, the universe was simply a place where things happened. Stars burned, exploded, scattered. Dust fell into clouds. Gravity sculpted shapes.
chemistry whispered among atoms, and for the longest time, nothing knew anything. But slowly, patterns emerged that could replicate. Life began as something tiny, fragile, almost shy, a whisper inside the ocean, a flicker of organization held together by nothing more than molecules learning to cooperate. These early forms didn't think or feel. They simply reacted. They followed the rules of physics like everything else. Yet as the oceans changed, life changed with them. Cooperation grew more complex. Molecules formed cells. Cells formed networks. Networks formed organisms with senses, ways of detecting the world around them, ways of responding to light, temperature, chemistry. And with each new step, life drifted a little closer to something extraordinary. The ability not just to react, but to perceive. Imagine the first flicker of awareness on Earth. Not a thought, not yet. Just a sensation, a response to light that wasn't simply automatic, but meaningful. A primitive creature sensing warmth, sensing danger, sensing change. A tiny tremor of experience, so faint it would barely register as consciousness today. But it was a spark, and sparks grow. As evolution marched on, these sparks grew into flames. Nervous systems emerged. Brains evolved, first simple, then elaborate, then astonishing. A brain is not magic. It's a physical system made from atoms and electricity. But the way it organizes information, the way it loops signals through webs of neurons, the way patterns reinforce or weaken or blend together, all of this creates something that feels a lot like magic.
And somewhere along that deep evolutionary journey, something subtle happened. A brain noticed itself. A mind became aware that it was a mind. And the universe, through that awareness, crossed a threshold. Before consciousness, the cosmos was silent. After consciousness, the cosmos had thoughts. You are one of those thoughts, a temporary ripple in the vastness, flickering brightly for a little while, carving meaning out of the fabric of space and time. This raises a gentle question, one that philosophers and physicists and poets have whispered for centuries. What exactly is consciousness? Is it a computation, a chemical reaction, a quantum phenomenon, or something else entirely? Something we don't yet have the tools to describe? Some theories suggest consciousness emerges from complexity alone, that once neurons form a network dense enough, a web with enough loops and branches, self-awareness simply appears, like a new note in a musical chord. Others suggest consciousness arises from information, from the way the brain moves, stores, and manipulates patterns. Still others think consciousness might be something deeper, a fundamental aspect of reality itself,
woven into the universe like space and time. And then there's the most intriguing idea of all, that consciousness might be connected to quantum processes happening inside the brain. Tiny vibrations, entanglements, quantum tunneling inside microstructures, so small and fragile, they exist on the border between the physical and the ephemeral. If this is true, if even a fraction of consciousness depends on quantum effects, then your thoughts are not just biological. They are quantum. They are born from the same uncertainty that governs electrons, the same superposition that shapes atoms, the same probability waves that ripple through the vacuum of space. That would mean your mind is not simply inside the universe. It's a reflection of the universe, a continuation of it, a soft personal echo of the same physics that ignited stars and painted galaxies across the cosmic canvas. You are a way for the cosmos to feel something, to wonder something, to ask questions of itself. And there's something peaceful in that idea, the notion that even your quietest late-night thoughts, even your drifting half-dreams, are connected to the deep structure of the cosmos. When you wonder why you are here, the universe is wondering too. When you breathe gently in the dark, you are performing an act that began 13.8 billion years ago. Expansion, cooling, organization, complexity, awareness. Your mind is the latest chapter in a book the universe has been writing since time began. And that chapter is still unfolding. Every new memory you form, every new connection your neurons make, every new sensation that drifts softly across your awareness, it's all part of the ongoing story of consciousness. So the next time you lie awake at night, listening to your breath, feeling the weight of your body sinking into the mattress, remember this: you are not separate from the cosmos. You are the cosmos, shaped into a form that can rest, that can imagine, that can dream. If you close your eyes now, just for a moment, you might notice something interesting. The world behind your eyelids isn't empty. It's filled with soft colors, drifting impressions, little echoes of memory and imagination blending together in a way that feels both familiar and mysterious. This quiet inner landscape, this space where thoughts stretch and blur, is one of the most fascinating creations of your consciousness, and it carries you gently into one of the deepest questions in quantum physics and neuroscience. How does the mind generate a world of its own? This is where we begin to drift into the science of dreams. Dreams are strange. They break rules you didn't know you had. They bend time, warp places, rearrange faces. They let you fly without wings, breathe underwater, meet people long gone, or wander through impossible landscapes painted by a version of you that isn't quite awake, but isn't fully asleep either. And yet, despite how surreal they feel, dreams arise from something incredibly physical. Electrical firings, chemical waves, patterns of neural activity drifting across the brain like wind across tall grass. What's beautiful is that dreams show us something important. The mind doesn't just react to the world, it creates worlds. Every night, when your body sinks into sleep and the outside world fades, your brain becomes a storyteller, weaving narratives that don't need consistency or logic, only emotion and momentum. And behind those stories lies a river of physics, ancient, intricate, and quiet.
During REM sleep, the stage where most vivid dreams occur, your brain becomes almost as active as it is when you're awake. Neurons light up like constellations. Networks buzz with patterns. But here's the curious part. The prefrontal cortex, the region responsible for logic, planning, and self-control, softens. It loosens its grip. This release is part of why dreams feel so fluid, so unbounded, why impossible things can happen without triggering doubt. It's as though consciousness loosens its anchor and drifts into deeper water. Some neuroscientists believe that dreams help your brain process emotions. Others think they're for memory consolidation, a kind of nighttime reorganization where the day's experiences are replayed, compressed, or discarded. And some theories go even deeper, suggesting that dreams might be the brain's way of predicting the future, rehearsing scenarios, exploring possibilities. But there's another angle, a quantum angle, that adds a new layer of intrigue. Some researchers propose that parts of the dreaming brain might rely on quantum effects, not in a mystical way, but in the sense that consciousness itself might involve processes that operate at the edge of classical physics. Quantum coherence, quantum tunneling, tiny fluctuations inside microtubules or synapses that shape the flow of information. If even a small piece of the dreaming mind is influenced by quantum uncertainty, then your dreams might be the place where the universe's deepest randomness becomes personal, where probability waves turn into imagery, emotion, narrative, where the indeterminacy of the quantum world is woven into stories that feel meaningful even when they don't follow the rules of ordinary reality. And then there is the question of awareness. When you dream, the boundaries of identity soften. You become both the experiencer and the creator, both the passenger and the architect. This duality mirrors something in quantum physics, the wave-particle duality, the idea that something can be two things at once until observed. In a dream, you are in a superposition of selves. You shift, you morph, you dissolve, and reform. You float between perspectives, between moments, between memories, and when you wake, the wave collapses. The fragments coalesce into one coherent self again. Is this just metaphor? Maybe. Or maybe the brain, at its deepest levels, really does rely on a kind of quantum logic, one that allows multiple possibilities to coexist
exist for a moment before the waking mind chooses one. Even the way dreams fade feels quantum. You wake up with images so vivid you could swear they were real, and then, within seconds, they dissolve like vapor. You reach for them, and they slip away. Their memory is delicate, prone to collapse. The act of trying to recall them often changes them. Just like observing a quantum state changes the state itself. It's tempting to think of dreams as random noise, but they're not. They're structured, emotional, symbolic. They reflect your fears, desires, memories, hopes. They recombine experiences you've forgotten into moments that feel strangely alive. And in doing so, they reveal something profound about awareness. That even when disconnected from the outside world, the mind continues to explore, create, and imagine. Dreams also blur another boundary, the one between the physical and the experiential. At their core, dreams are electrical impulses in a biological organ, but subjectively, they feel like entire worlds. How does something physical create something so internal, so personal, so vivid? This question, the hard problem of consciousness, is one of the great mysteries of science. How does matter give rise to experience? How does the activity of neurons produce the feeling of existing? We don't know. Not yet.
But we do know that consciousness doesn't switch off at night. It simply shifts shape. It relaxes, unfurls, allows itself to wander. And in that wandering, truths can surface that daylight hides. You might meet a version of yourself you didn't know existed. You might confront fears you ignore. You might solve problems in ways that feel spontaneous. You might imagine worlds that no telescope has ever seen. It's a quiet reminder that the universe inside you is just as expansive as the one outside. And when you dream, those inner galaxies come alive. As your mind drifts through this nocturnal landscape, something extraordinary happens. The brain begins to repair itself. Neurons prune old connections. New pathways strengthen. Chemicals rebalance. The mind restores its clarity. The body heals. Sleep isn't just rest. It's reconstruction. Every night you are rebuilt on a microscopic level, and every morning you wake slightly renewed, slightly reshaped, like a new star forming from the remnants of something older. And somewhere in that process, that beautiful interplay of biology and physics, you find yourself again, a self that continues to change with every breath, every memory, every dream. If you listen closely, not with your ears, but with that quiet sense inside you, you might notice something subtle about the world. It is filled with patterns. They appear everywhere, from the spirals of galaxies to the whorls of fingerprints, from the symmetry of snowflakes to the rhythm of your heartbeat.
branching of lightning to the branching of neurons in your brain. Even your thoughts have patterns, looping, expanding, drifting, settling, a constellation of ideas forming and dissolving as softly as clouds. This universal tendency toward pattern isn't just beautiful. It reveals something deep about how the universe organizes itself. And understanding that takes us into one of the most soothing truths of physics, that order can emerge from chaos, structure can bloom from randomness, and meaning can rise from a universe that began in pure, searing simplicity. It's hard to imagine now, but right after the Big Bang, there were no patterns at all, no stars, no planets, no molecules, no atoms, just an expanding sea of particles and fields in constant, frantic motion, pure chaos. But hidden inside that chaos were tiny fluctuations, ripples of slightly different densities, not planned, not intentional, just random variations left over from the quantum foam of the universe's earliest instant. And yet, those tiny ripples became everything. Where the universe was slightly denser, gravity pulled harder, gathering matter into clouds, clouds into clumps, clumps into protostars, protostars into blazing suns, suns into spiraling galaxies, galaxies into clusters stretching across billions of light years. Out of noise came structure. Out of randomness came design. Out of simplicity came complexity. This tendency, this drift from chaos toward order, is one of the universe's most gentle and persistent habits. And remarkably, you are part of that same habit. Your body is a masterpiece of organized complexity. Billions of cells, each containing molecular machines working with astonishing precision. DNA strands coiling into spirals, proteins folding into shapes that allow life to function, neurons firing in intricate patterns, generating thoughts, memories, emotions. It is easy to forget, but nothing about you is simple. You are the product of 13.8 billion years of physics, sculpting complexity out of simplicity. But what's even more beautiful is this. The universe didn't need anyone's permission to do this. It didn't need a blueprint or instructions. Order emerged because the rules of physics allow it, because gravity collects, because chemistry bonds, because quantum fields interact in ways that let stable structures form. The universe doesn't force order. It invites it. It encourages it gently, quietly, patiently. And it continues even now, inside you. Every thought you have is a sudden flash of order arising from billions of neurons, each one influenced by tiny electrical shows how something as physical as ions flowing across membranes can produce something as subjective as longing, joy, curiosity, or the quiet softness you might feel right now.
You are a pattern the universe created, not a random one, not an accidental one, a deeply structured, evolving, self-aware pattern. A ripple of meaning emerging from fields and forces older than time itself. Some scientists believe that this emergence, this gentle, persistent blooming of complexity, may be one of the most fundamental truths of nature, a principle that guides everything from particle interactions to galaxy formation. And if that's true, then consciousness itself might not be an anomaly. It might be the natural extension of the universe, learning to organize itself at higher and higher levels. Think about that for a moment. When you feel gratitude, when you imagine a future, when you remember a moment from childhood, when you look at the night sky and wonder where you fit within it, the universe is doing that through you. It took billions of years for hydrogen atoms to gather, fuse, explode, reform, bond, and evolve into a mind that can ask questions, a mind that can feel something, a mind that can dream. Dreaming itself is a perfect example of how order and chaos dance together in the brain. You fall asleep, your neural networks loosen, your sense of self softens, your memories drift into new configurations. In that liminal space between waking and dreaming, the brain stops insisting on logic. It lets randomness enter. It lets chaos whisper. And from that whisper, new connections form. Ideas you've never thought before. Emotions you've never named. Insights that rise from nowhere. Even creativity, the spark that makes you imagine a story, or picture a world, or solve a problem, emerges from the interplay of order and randomness. The structured parts of your mind guiding the flow, the chaotic parts providing the surprises. Creativity is the gravitational collapse of thought, the moment when scattered ideas fall into a new pattern. The universe creates through you the same way it created stars. It gathers, it balances, it resonates, it refines. And that's why your experience matters. Not because the universe needs it, but because the universe is it. You are a continuation of a cosmic pattern that began long before Earth existed. A ripple in the grand tapestry of emergence. There's something very peaceful in recognizing this, that you don't need to fight the unknown. You don't need to have every answer. You don't need to solve the entire universe. You are part of a process that began long before you and will continue long after. A process that naturally creates order from chaos, clarity from confusion, meaning from mystery. You don't have to be certain to be complete. You can rest in the unfolding. You can breathe into it.
yourself drift, because the universe is still shaping you, still sculpting you, still discovering itself through your quiet awareness. Time, it's such a familiar thing, isn't it? You feel it in your breath, in the slowing rhythm of your heartbeat as you relax, in the softness that settles over you as your eyes grow heavy. Time flows through your life like a gentle river, always forward, never backward, always carrying you from one moment to the next. Yet, for something so constant, time is also one of the most mysterious ideas in physics. We all know what time feels like, but what is it really? Why does it move in just one direction? Why does the past feel fixed while the future feels open? These questions lead us into one of the deepest, most soothing puzzles of the universe, the arrow of time. If you were to look at the fundamental laws of physics, the equations that govern particles, atoms, galaxies, you'd notice something strange. Most of them don't care about direction. They can run forward or backward, and the math still works perfectly. In the microscopic world, time doesn't seem to have a preference. A particle bouncing off another particle behaves the same, whether you watch the video forward or backward. But our experience, our lives, tell a different story. You remember yesterday. You do not remember tomorrow. You age. You grow. You change. You move from morning to evening, never the other way around. Ice melts, but melted water doesn't spontaneously turn into a perfect cube. Air spreads out, but never gathers itself back into a corner. Stars burn fuel, but never unburn it. This one-way movement, this irreversible flow, is the arrow of time.
And that arrow is drawn by entropy. Entropy is often described as disorder, but that's not quite right. It's better understood as the number of possible ways something can be arranged. High entropy means many possible configurations. Low entropy means few. The universe began in a state of extremely low entropy. Simple, smooth, incredibly uniform. And over time, it has been drifting toward higher entropy, toward complexity, toward disorder. And that slow drift is what gives time its direction. Entropy increases, eggs break, stars burn, universes stretch, and we move with that flow, like leaves carried downstream. Time feels like a river, not because it forces us forward, but because the universe is gradually unfolding into more and more ways it can exist. Even your memories are tied to entropy. You remember the past because your brain formed a stable, low entropy pattern of neurons that encoded it. The future, by definition, has not yet been organized. It has infinite possible shapes. It's wide open entropy. There's something deeply calming about this. The arrow of time isn't a burden. It's a gentle consequence of the universe expanding, cooling, and settling into new patterns. It's the universe exploring itself, and you, right now, are part of that exploration. What's even more remarkable is that the arrow of time is intimately tied to gravity. In the early universe, matter was almost perfectly spread out, a near uniform fog. But gravity doesn't want things to stay spread out. Gravity wants to clump, to gather, to collapse. And collapsing increases entropy because it creates more possible microstates, more ways matter can arrange itself. When stars form, entropy increases. When galaxies form, entropy increases. When black holes form, the most extreme gravitational structures, entropy increases more than anything else. In fact, black holes have the highest entropy of all objects in the universe. They are like cosmic furnaces where the arrow of time burns hottest. And yet, black holes also preserve something surprising: symmetry. Symmetry is one of the most elegant ideas in physics. It means that something stays the same under certain transformations, like rotating a perfect sphere, or flipping a mirror image, or shifting something in time. Symmetry is woven into the laws of nature. It guides how particles behave, how forces unify, how fields interact. In some ways, symmetry is the universe's way of maintaining balance, even as entropy grows. Order dissolves, structures collapse, but the deep mathematical symmetries remain unbroken beneath it all. It's like the scaffolding of reality, invisible but essential, giving shape to everything from atoms to galaxies. Inside your body, symmetry and entropy dance in their own quiet rhythm. Cells break down and rebuild. Proteins fold and unfold. Memories form and fade. Your brain constantly balances order and disorder, structure and change. Even your sense of time, the way a moment feels long or short, the way memories drift closer or further, is shaped by the unfolding of entropy in your neural networks. But there's something beautiful hiding inside this physical truth. Without entropy, you couldn't exist. No metabolism, no warmth, no breath. The flow of time is what allows your body to stay alive, for energy to move, for heat to travel, for chemical reactions to occur. The same physics that drives stars to shine also drives your cells to function.
stories is only because entropy increases, that without this growth in possibilities, the concept of past and future might not exist at all. In that sense, time is not a fundamental feature of the universe. It's a story the universe tells itself as it changes, and your life is one of those stories. You are a brief, beautiful chapter in the universe's expansion, a moment where matter arranged itself with such precision that it could wonder about where it came from, a ripple of awareness, a structure capable of remembering, dreaming, longing, loving. Your existence is an exquisite entropy gradient, a movement from order toward complexity, toward experience. And as you relax deeper into this moment, with your breath softening and your thoughts slowing, you can feel that movement in your body, the warmth in your chest, the gentle rise and fall of your breathing, the way your awareness shifts like a tide. Time moves forward and you move with it. No hurry, no resistance, just a quiet flow.
Soon, we'll drift into something even more mysterious. The fabric of space-time, the nature of gravity, and the hidden layers of reality that might exist beneath our perception. When people hear the word entanglement, they often imagine something chaotic, threads knotted together, vines twisted tightly in a forest, or headphones somehow tying themselves into impossible knots in your pocket. But quantum entanglement, it isn't chaotic. Not really. It's strangely gentle, so subtle, almost tender. It's the softest bond the universe can form, a whisper of connection between two particles that says, wherever you go, I'm with you. And tonight, as you settle deeper into wherever you are, under a warm blanket or resting your cheek on a cool pillow, I want you to imagine something simple. Two tiny sparks of light drifting near one another in the quiet dark. No sound, no temperature, no space that feels familiar. Just a kind of cosmic silence, a primal stillness. These two sparks form together in a single event, born from the same flash of energy, the same quantum shiver. And in that moment, a rule is written between them, a rule not carved in stone or wrapped in math on a chalkboard, but woven into the very architecture of reality. A rule that says, your stories are linked, no matter how far you drift. Now imagine those two particles separating. One moves left, the other right. One drifts upward, the other downward. They part like two tiny ships pushed apart by a gentle tide. Seconds pass, then minutes, then years, then light years. They become so far apart that even a beam of light would take centuries to travel between them. But in the quantum world, distance isn't what it seems. Because if you nudge one of those particles,
question like, who are you right now? The other particle, no matter how impossibly far away, will respond instantly, not through a signal, not through a message, but because they were never truly separate to begin with. They were two pieces of the same quiet equation, two halves of one story. Einstein hated this idea. He called it spooky action at a distance. And honestly, who could blame him? It is spooky, but not in a frightening way. More like standing outside at night and realizing there are more stars than you could ever count. It's not scary, it's humbling, because entanglement whispers something incredibly profound. The universe is more connected than it looks. Even in the deep vacuum between galaxies, in the dark, cold places where no sound can travel, connection remains, quiet, invisible, unbroken. And maybe that tells us something about ourselves too. Maybe it means that we are not as isolated as we sometimes feel, that no matter how separate our lives can seem, different cities, different nights, different worries, different dreams, we are still woven into something larger, a cosmic fabric that doesn't tear easily, a network of existence where nothing is ever truly alone. Not really. Let that thought rest on you for a moment, like a warm hand placed gently on your shoulder, like the soft weight of a blanket, like the hush of breath just before sleep. Because entanglement isn't just a physics concept, it's a comfort too. The idea that distance doesn't always mean disconnection. But tonight, let's step deeper into the geometry underneath it. If you could see the mathematical structure of entanglement, truly see it, it wouldn't look like wires or threads. It wouldn't look like strings or lines stretching across space. It would look more like symmetry, a mirrored pattern, two shapes that remain linked no matter how far apart the paper is folded. It's less like a rope tying two particles together and more like a reflection linking two sides of a lake. Touch the water on the left side, the reflection on the right ripples instantly, not because the two sides spoke to each other, but because they were always part of the same surface. This is the essence of quantum reality, a universe where separation is sometimes an illusion, and connection is woven deeper than our senses can reach. And as strange as this is, as dreamlike as it sounds, entanglement is not rare. It's not some exotic, unreachable phenomenon hiding in labs and textbooks. It's everywhere, constant, fundamental. Every chemical reaction in your body uses it. Every photon in your eyes relies on it. Every atom in the universe has danced through it. Some scientists even wonder if consciousness itself, this soft glow behind your thoughts, might rely on structures where entanglement a subtle role.
We don't know. And that's okay. Because the beauty of the quantum world isn't that it gives us perfect answers. It's that it invites us to rest in wonder, to lie back, breathe softly, and accept that not everything needs to be fully understood for us to feel its presence, just like the night sky, just like the ocean, just like sleep. Entanglement may be the universe's quietest love story. Two particles drifting apart, but never losing track of each other, never forgetting the relationship written into them at the moment of their creation. And maybe, in a gentle way, that's true for us as well. Maybe the connections we form, the people who matter to us, the moments that shape us, stay written into us, even as life carries us in different directions, even when distances grow, even when time stretches. Maybe nothing meaningful is ever truly lost. Maybe everything remains subtly entangled. So as you settle deeper into your pillow, letting your breath soften and your thoughts drift, you can imagine that somewhere out there, scattered across the dark sea of the cosmos, particles are whispering to one another, moving in harmony, responding in sync, connected across distances so vast it makes the heart flutter. And yet the universe handles it effortlessly, quietly, elegantly, as if to say, connection doesn't need closeness, it only needs origin. And the origin of everything, every star, every atom, every breath, was the same unimaginably bright moment. Maybe on some deep level, we're all still entangled with that beginning, still sharing a quiet symmetry with everything that exists, still part of one vast, shimmering reflection. Let that thought settle. Let it soften your shoulders. Let it ease your chest and your jaw. The universe is strange, yes, but it is also gentle, so gentle. And as you drift within it, held by it, connected by it. If you've ever lain on your back and looked up at the night sky, maybe you felt it, that strange sense that the world beneath you dissolves, and suddenly you're not lying under the stars. You're lying in them, that the earth is not a floor, but a drifting platform in a vast, quiet sea, that above you and below you aren't really opposites, but directions on a map so enormous and gentle that your body almost forgets which way is which. That feeling, that soft, dizzy sense of floating, is your mind brushing up against the true nature of space-time. We tend to think of space as emptiness, a cold void, a backdrop, a stage where planets and stars perform. And we think of time as a steady ticking, a slow march, a river that flows in just one direction. But in reality, space and time aren't separate things. They're woven together into a single fabric, space-time. And it doesn't just sit there passively. It bends, it ripples, it curves, it flexes around mass and energy, the way a blanket dips when you place a warm, sleeping cat on top of it. We live inside that blanket. We move across it. We age within it. We dream inside its folds. And tonight, we're going to drift into the softness of that fabric, the geometry underneath reality itself. Take a slow breath. Let your body relax a little deeper. Let the day loosen its grip on your shoulders, because space-time doesn't rush. It doesn't demand anything. It simply exists. A quiet ocean stretching in every direction, holding galaxies the way gentle waves cradle drifting boats. Einstein didn't discover gravity. People have known about falling apples and dropping stones for as long as humans could look around. What Einstein discovered was the meaning behind it. He realized that gravity isn't a force pulling things down like invisible hands tugging on your ankles. Gravity is geometry. When you drop a pebble, it falls not because Earth pulls it, but because the pebble is moving along the curved shape of space-time itself. The world beneath your feet is not flat, but gently warped, and the pebble simply follows the natural slope. It's like placing a marble on a soft mattress. The marble doesn't fall because an invisible string yanks it. It falls because the mattress dips. Earth makes a dip in space-time. So does the sun. So does your body. Even the warmth of your breath has a tiny, tiny influence. Mass tells space-time how to curve, and space-time tells matter how to move. It's a beautiful sentence. Soft, balanced, almost poetic. And it describes the choreography of the entire universe. Think of planets orbiting stars, not as rocks circling fiery spheres, but as objects gliding along curved grooves, carved gently into the space-time fabric. Think of light bending around galaxies, not because it wants to, but because the path itself bends like a river flowing through a valley. When a star collapses into a black hole, it presses so deeply into the fabric that the geometry stretches to its breaking point. Not broken, as in destroyed, but stretched into a shape so steep, so extreme, so steeply curved, that not even light can climb out. Imagine holding a sheet of cloth and pressing your finger into it. At first, the cloth dips a little. Press harder. It dips deeper. Press with everything you have, and the cloth forms a funnel. That funnel is a black hole, a place where the fabric has curved so dramatically that all paths lead inward. But here's the most soothing truth. Space-time isn't rigid. It's not a brittle crystal or a cold metallic frame. It's soft. It's elastic. It's responsive. When something moves, the fabric shivers. Tiny ripples called gravitational waves. When two black holes merge,
They create waves that spread across the universe, like the rings you see when a pebble touches the surface of a pond. These waves travel through everything, through planets, through clouds, through your body, through the pillow under your head. When LIGO first detected them in 2015, the signal was unbelievably faint, stretching Earth itself by less than the width of a proton. And yet, it was real. A whisper from two black holes colliding a billion years ago. A reminder that space-time is alive with motion. And you are resting right now inside this living, breathing fabric. Feel that for a moment. Not in a literal sense, not as something dramatic, but as a quiet realization. You are floating inside a medium that curves gently around you. A medium that supports your existence without effort. A medium that connects you to everything, from the atoms in nearby air to stars impossibly far away. Now, let's drift even deeper. Imagine space-time not as a smooth sheet, but as something finer, something grainy, something woven from threads too tiny for us to see. Some physicists believe space-time might be quantized, made of minuscule units like pixels or woven knots. The smallest possible distances, the smallest possible moments. If true, the universe would be like a blanket knitted from loops so small they barely exist, and yet they hold everything together. Every star, every planet, every thought arises from that fabric. Time itself, in this view, becomes something like a sequence of frames, flickering so quickly your mind perceives them as one continuous flow. Space becomes a lattice, so small it makes the idea of small feel enormous. And the strange thing is, this picture doesn't make reality feel more mechanical. It makes it feel gentler, more intimate, as though existence is hand-stitched. There are theories, like loop quantum gravity, that describe space-time as a vast web of tiny knots, each knot representing a quantized area of space. The universe becomes a tapestry where geometry is woven from discrete stitches, and motion is just the shifting of these tiny knots. Other theories paint space-time as an emergent phenomenon, something that rises from deeper structures, the way temperature rises from molecules, or the way consciousness arises from neurons. In those theories, space-time might not be fundamental. It might be a story the universe tells as it organizes itself, a story you are living inside, sleeping inside, breathing inside. And perhaps the most comforting idea is this: whether space-time is smooth or granular, whether it is fundamental or emergent, it holds you effortlessly. Right now, as your eyes grow heavier, you are floating in a cosmic fabric that bends gently around your body, a fabric that knows how to carry stars, a fabric that expands quietly every moment, stretching space itself, soft as breath, a so large and so diffuse that galaxies drift apart like lanterns on a lake. But not tonight. Tonight, everything is close and quiet. Tonight, space-time feels like a cradle, wide enough to hold galaxies, gentle enough to hold you. You can let yourself rest inside that. You can let your thoughts drift like planets orbiting softly. You can let your mind settle the way dust settles in a sunbeam, slowly, peacefully, weightlessly.
Because the universe is not in a hurry. And tonight, neither are you. There's a moment late at night, maybe you felt it, when the world becomes strangely gentle. Sounds soften, colors dim, thoughts turn from sharp angles into smooth curves. Everything feels slower, broader, as though your mind has stepped just slightly outside the usual rhythm of things and now exists in a quieter, wider space. This is the perfect place to talk about the edge of reality, not the edge like a cliff or a border, but the edge where our understanding slowly dissolves into mystery, the place where physics blends into philosophy and philosophy blends into something even calmer, something like dreaming. Because for all the equations and experiments and elegant theories, there are still questions that sit like lanterns in the distance, glowing softly, never fully approached. Questions so fundamental, so quietly enormous, that even the greatest physicists in history felt a kind of awe standing before them. What is reality? What does it mean to exist? Why is there something instead of nothing? And beneath all of that, why does the universe feel ordered at all? These are not questions science can answer in the traditional sense. They are too large, too open, too softly shaped. But quantum physics, in its strange, almost dreamlike way, gives us glimpses, little reflections on the surface of a deep pool that hint at the truth hiding beneath. Take the vacuum, for example. Most people imagine the vacuum as emptiness, a cold nothingness. But to a quantum physicist, the vacuum is one of the busiest, liveliest places imaginable. It boils with activity. It hums with temporary particles, virtual excitations that appear and disappear so quickly they barely exist, yet still influence the world in measurable ways. The vacuum is not nothing. It's a canvas of possibilities, and that alone changes everything. Because if the vacuum is full of potential, then the universe isn't built atop emptiness at all. It's built atop a deep, restless sea of maybes and almosts and could-bes, a sea that never truly rests. Let that idea float gently in your mind. The universe hums, even in silence. It flickers, even in darkness. It breathes, even in stillness. Now imagine zooming in, deeper and deeper, past atoms, past quarks, past fields, past even the concepts we use to describe them. If you keep going, you eventually reach a point where the language of physics begins to fail, where the words particle and wave stop being helpful, where space becomes uncertain, where time wavers, where existence itself feels fuzzy and indistinct. And here, at this deepest layer, something beautiful happens. You discover that everything is relational. Nothing exists alone. Nothing has meaning in isolation. Everything, particles, fields, forces, even space-time itself, exists only through connection. A particle's properties are defined by how it interacts. A field is defined by how it vibrates. Space is defined by how matter curves it. Time is defined by how things change. Reality is not a collection of objects. It's a network of relationships. And you, your thoughts, your memories, your sleeping body lying quietly right now, are part of that network. You are woven into the same relational fabric. You exist not as an isolated dot, but as a glowing intersection of countless influences. Physics, chemistry, biology, experience, emotion, history, and chance. You are a vortex of relationships held together by gentle patterns of energy and matter that persist long enough to be called you. Let that bring you comfort. You are not alone in the universe. You couldn't be alone even if you tried. Everything that exists is tied to everything else by the quiet geometry of reality. Even your consciousness, this soft awareness drifting through the present moment, might be emergent from the way neurons interact, the way quantum events flutter, the way information flows. You are the universe become aware of itself just for a moment, just long enough to notice its own depth. And there is something deeply, deeply peaceful in that. Now consider time again, but not the rushing, hurried time of clocks and appointments. Consider time as a landscape, a terrain, a quiet four-dimensional expanse where all moments exist at once. The past, the present, the future, all laid out like pages in a book. In this view, your life is not a narrow path you're forced to walk. It's a tapestry that already exists in full, every thread woven in place. You are simply moving your attention along it, exploring it, breathing your way through it. The future isn't being created as you go. It's already part of the fabric. The past isn't gone. It's still there, woven softly behind you. The present is the place where your awareness rests for a moment. In this picture, nothing is truly lost. Moments don't vanish. They simply exist elsewhere in the tapestry. Memories don't evaporate. They remain etched into the structure of space-time. And when you sleep, when your mind loosens its grip on the immediate moment, it may drift through that landscape freely, wandering among memories, weaving new paths, exploring places your waking mind would never think to look. Dreams might be your consciousness, taking a quiet walk through the geometry of your inner world. And the universe dreams too. It dreams galaxies into existence. It dreams stars into fusion. It dreams atoms into life. It dreams minds capable of wondering about themselves. You are part of that dream, a brief, luminous thought in the universe's long night. As you breathe softly, letting each inhale draw you deeper into calmness, you can imagine the fabric of reality supporting you like a warm ocean. Imagine space-time curving gently around you, not as something cold or mechanical, but as something soft, welcoming, alive with quiet order. Your body sinks deeper into the bed or couch or chair beneath you. Your muscles unwind at their own slow pace. Your mind softens, drifting like a lantern on still water, and the world around you becomes gentle, dim, weightless. Nothing is demanding your attention now. Nothing is rushing you. The universe has waited 13.8 billion years to become what it is. It can wait a little longer while you rest, because you are not separate from it. You are a continuation of it, a gentle ripple in space-time, a momentary pattern of particles humming in harmony. You are the cosmos taking a slow, deep breath. Everything you are and everything you feel is part of the universe's unfolding. And as you float in this quiet awareness, soft, relaxed, drifting, you become part of the calmest truth in physics. The universe is vast, but it is not empty. It is silent, but it is not still. It is strange, but it is not unkind. It holds you gently, always has, always will. And now, your eyes may be heavy, your breath slow, your thoughts drifting like dust in a sunbeam. Let yourself rest. Let the universe carry you. Let the story fade into silence. You are safe. You are warm. And the cosmos is still here. Softly